All right, people. I believe everybody is doing great, nice, and absolutely fine. Let me know in the chats if I am perfectly audible and visible properly. Let me know in the chats if I'm perfectly audible and visible. Okay. Good evening, good evening, good evening. So, what's up, people? I believe everybody is doing great, nice, and absolutely fine. Let me know in the chats if I am perfectly audible and visible. Okay. We have to finish this kinematics 1D entire chapter today. Okay. And we will finish it. That's for sure in 2 and 2.5 hours. Okay. Okay. And I will be starting from the scratch. I will be starting from the scratch. And before that, if you have not liked the session yet, do like the session as soon as possible. Okay. Do like the session as soon as possible because marking the attendance is very much mandatory. Marking the attendance is very much mandatory over here. So I want you guys to basically like this particular session as soon as possible, as soon as possible. And let the people join, and we are starting accordingly. We will start accordingly this particular chapter. Before that, let me know in the live chat, how is everything going? How is everything going? Okay. How is your preparation going? Okay. So we will have to finish this kinematics 1D today. Okay. Every pattern of question, whatever, every pattern of problem, whatever has the probability to come in the upcoming NEET, will be solving that problem over here. Okay. Good evening, good evening, good evening, good evening. Okay. And before that, let me just tell you, my dear people over here, when it comes to the Unacademy Learning Festival, okay, we have already told you this learning festival is basically, this is completely free of cost. You can enroll in the plus batches of Unacademy inside, completely free of cost. The link is given in the description below. If you haven't joined it, join it as soon as possible. And if it asks for the code, you can use my code, that is YAWAR. Okay. That is YAWAR. Okay. So, my dear friends, now let's move on to our chapter. Okay. Without wasting the further time, I know time is precious right now. So, without wasting the further time, we will start our chapter. I hope everybody has joined. Everybody has joined. Okay. Yes. Great, 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 great. Now, listen to me very carefully. Listen to me very carefully. Let's start this particular chapter over here. Make sure you like this session, guys. Liking the session is very much mandatory. Everybody out there, I'll teach the ray optics also. Do not keep on asking me in the live chat, sir, when will you start the ray optics? When will you start the ray optics? It's my job. I will teach you ray optics. I will teach you wave optics on this particular channel. That's for sure, 100%. Okay. Now, my dear people, first of all, in this particular session, we will have to start this kinematics 1D. See, guys, I have the high energy. I want you guys to show the same energy in the chats, okay, with the fire emojis. Now, see, if we talk about this particular chapter, the first topic that we need to understand, that we need to learn over here is, we say, sir, distance, and we say this displacement. We have to learn the distance and displacement. Sir, what does this distance and displacement say? Now, listen to me very carefully. Let's suppose you live at this particular point. This is your house. Let's suppose this is your house, that is A. Okay. And we say this is your friend's house. That is what we call B. This is your friend's house. That is B. Okay. Now, my dear friends, you have to go from your house to your friend's house. You have to move from A to B. Listen to me very carefully. I say you have got the different roads over here while moving from A to B. This is, let's suppose this is what we call the path 1, or we say P1. This road which government has constructed, this is what we call the path 1, or we say P1 over here. Okay. Now, my dear friends, let's suppose we have got one more path that is something like this. And this path is, we say, sir, let's suppose P2, or we say, sir, this is the road 2 from A to B. Okay. Now, my dear friends, let's suppose we have got one more path, something like this. And this is, we say, sir, P3. This is, we say, sir, P3. We have got the different paths. If we have to move from this point A And if we have to reach this point B, we have got the different paths over here. Now listen to me very carefully how I will make you understand the distance and displacement. If I say, my dear friends, if I am moving along the path 1, if I am moving along the path 1, means I am covering the distance. Moving, traveling means covering the distance, okay? If I am moving along the path 1, means I am covering the distance, okay? Now, my dear friends, if I am moving along the path 2, I am also covering the distance, okay? As of now, you just remember it is also the distance. And if I say, if I am moving along the path 3, we say I am also covering the distance over here. Now listen to me very carefully. Sir, when it comes to this path, we say, sir, this path 2 is a special type of distance. All the 3 are over here distances. As of now, you just remember, all the 3 are over here distances. But when it comes to this path 2, this is a special type of distance. I'll just write over here. I'll take it. I'll just write over here. When it comes to, we say, sir, P2, it is a special type of distance. It is a special type of distance. Sir, why is it special type of distance? We say it has got a unique direction. Unique direction. It has got a unique direction. Sir, what unique direction? We say it has got a proper direction from A to B. Clearly, you can say, sir, it has got a unique direction. Sir, what about this path 1 and path 2? What about this path 1 and path 2? Sir, in this case, over here, this is the direction of the path, and over here, this is the direction of the path. This is the direction of the path. This is the direction of the path. Means, when it comes to path 1, it has got different directions, not a proper direction. Sir, when it comes to this path 3, it also has got different directions. Over here, it is this. Over here, it is this. It is this. So, it has got different directions over here. But when it comes to this one, it has got a unique direction. It has got a proper direction. So, we say this is what we call the displacement. Displacement. So, means this is this one. It is called the displacement. And one more point you can add over here. Sir, this path, this middle path over here, this is also called, listen to me very carefully. This is also called, we say, sir, the shortest path. Sir, from A to B, if you see which one is the shortest path, clearly you say, sir, this one is the shortest path from A to B. Sir, this is the longer one, okay? This is less than that, but this is the shortest one. Now, my dear friends, listen to me very carefully. Let's suppose, if I say you have to move from A to B, if I say you have to move from A to B, you have got two paths over here. Sir, first one is, let's suppose this, and the second one is, let's suppose this, okay? Let's suppose you are traveling along this path. Means you are covering the distance over here. If I say to draw the displacement from between A and B, you will simply say, sir, take this point A, take this point B, join these two with a straight line. So this will be, in this case, displacement. This will be, in this case, displacement. Displacement means shortest path. Join the initial point with the final point, you will get the displacement. And this one, which you have actually covered, this one which you have actually covered, this is what we call the distance. This is what we call the distance. Let me know in the chats if everything is clear. Let me know in the chats if everything is clear with the fire emojis, guys. We say from A to B, this is what we call the displacement, shortest path. Displacement is also distance, but what? Special type of distance. It has got a proper direction. It is the shortest path. And this is, we say, actual path which you have covered. Now, my dear friends, if I mention few of the points over here about the distance, can I say, sir, this distance is simply, it is the actual distance covered. It is the actual distance covered, since while you were moving from A to B, you were moving along this path. This was the actual distance. But if I tell you to write the shortest path, so this will be the shortest path, that is displacement. So I can say over here, sir, this distance is the actual distance covered. This distance, it is the actual path covered, actual distance covered. Okay, it cannot be negative, it is always positive. It has only magnitude, it does not have the direction. Now listen to me very carefully. Listen to me, basic points I am saying. Basic points I am saying. Listen to me very carefully. Sir, when it comes to the displacement, can I say this displacement, it is the shortest path between A and B? 110%, sir. Okay. Sir, we say it is always a straight line over here. Join the initial point with the final point with a straight line. It will give you the displacement. Yes, sir. We say it has magnitude. Sir, how many meters? 10 meter, 15 meter, as well as it has a proper direction. It has a proper direction. It has magnitude as well as a direction, as well as the direction. Now, my dear friends, one more important point that I want to mention over here. We say, sir, this displacement, listen to me very carefully. This displacement, it can be positive, it can be negative, and it can be zero also. Means displacement can be positive, it can be negative, and it can be zero. Guys, I hope you are getting each and every single thing. Why? Because when it comes to the displacement, we say how much the particle has displaced. Displacement means how much the particle has actually displaced. Let's solve a particular question. Let's solve a simple question over. Listen to me very carefully. Listen to me very carefully. Before this, I just need to tell you in this particular case, let's suppose, my dear people, listen to me very carefully. Let's suppose you are moving from point A and you are reaching point B. Okay. And then after B, you are moving to the point C. That is exactly over here. That is exactly over. This is the point C. Now, in this particular case, I say, sir, how much is the distance traveled from A to C? You say, sir, distance traveled means actual path covered. Sir, actual path covered is this distance plus this distance. Let's suppose this is x1, this is x2. In this case, we say, sir, distance is simply x1 plus x2. That is the actual path covered from A to B, B to C. And if I ask you to tell me what is the displacement over here, you say, sir, join the initial point with the final point. This will be the displacement in this particular case. And let's suppose this is x3. x3, you can calculate hypotenuse square is equal to base square plus perpendicular square. So I'll just write directly over here, displacement is x3. Why? Because displacement means how much you have displaced actually. How much you have displaced actually. So this is the initial point. This is the final point. Means this x3 you have actually displaced from your original position. I hope this is clear. Now, let's suppose, my dear friends, this is the observer over here. Sir, what does observer mean? Let me just give you a bit of a feel about the observer, because this will help us to solve the questions further. See. My dear people, let's suppose there is a person over here which is moving with a speed of 20 meters per second. I say, sir, there is another person on the ground. So we say with respect to this person is moving with a speed of 20 meters per second. Means in this case, this will be the observer. With respect to what you are talking about, let's suppose I say, there is a tree over here. So with respect to this tree, this car is moving, let's suppose, at a speed of 50 meters per second. In this case, this is the observer. Observer means with respect to what you are talking about. That's it. We don't have to go in much detail. This is a basic terminology. Now, come over here. Let's suppose this is the observer or this is the origin over here. My dear friends, the car is traveling from this point to this point. Let's suppose it reached the point A. And then after some time, it reached the point B. Listen to me very carefully. I say, sir, when the car is at point A, how much is the displacement? You say, sir, from the observer till this point, the displacement is, we say, sir, 10 meters. And in this case, we say, sir, if guys, if this is the origin, so this will be +1, +2, +3, +4, up to 10. So in this case, when the car is at point A, we say in that case, displacement is, we say, sir, +10 meter. It is +10 meter. Displacement is +10 meter. Okay. Yes. Now, if I say, my dear friends, when the car is at exactly B point, when the car is at B point, how much is the displacement? Sir, it is on the left side of the observer. It is on the left side of the origin. In this case, we say, sir, displacement is -10 meters. So that's why I told you, displacement can be positive, negative, as well as zero. As well as zero. It depends where the person is actually, how much it has displaced. Guys, we say, sir, with respect to the observer, it has displaced 10 meters only. But since this is -10 over here, that's why I'm mentioning -10. With respect to this observer, which is present over here, it has displaced, we say, sir, +10 meters. Okay. And we say, if the car is at C, let's suppose this is C, we say, sir, displacement in that case would be 0. We say, sir, at C, displacement is equal to 0. Guys, tell me in the chats if everything is crystalline clear. Tell me in the chats if everything is crystalline clear. All the people out there, I want every one of you to tell me in the chats. Tell me, guys, is everything crystalline clear? And make sure you hit the like button. Make sure you hit the like button. All the people out there, if you have not liked the session yet, I want you guys to like this particular session as soon as possible. As soon as possible. Okay? Okay. Like this session, guys. Like this session. Make the like count 300 plus. Make the like count 300 plus. Now listen to me very carefully. So we are done over here. Let's suppose we have got one more question in this particular case. That is it clear, guys? Tell me in the chats, bro. Everything is sorted. Everything is sorted, huh? I will tell you every single point over here, but make sure you stick till the end in this particular session. Let's suppose we have got a question something like this. We are supposed to find distance and displacement. Let me make you understand. Let me make you understand. See, guys, let's suppose initially you are standing at point A, okay? So you started from this point A. Listen to me very carefully. You started from this point A. Then you were traveling from A to, and you reached this point X, okay? Then you came back and reached this particular point over here. So from this point to this point, distance is how much? We say, sir, how much is this length? That is 4 meters. And from this point to this point, how much is the distance? We say, sir, 3 meters over. If I ask you, can you please tell me how much is the distance traveled in this journey? You say, sir, distance is the actual path traveled. So actual path traveled in this case is how much? From A to X is 4 meters. From X to this point, let's suppose this is Y. From X to Y is 3 meters. So that is 4 plus this 3 is 7. So I say in this case, when it comes to the distance, we say, sir, that is 7 meters. We say that is 7 meters. Actual path traveled, net path traveled. Okay, not net, actual path traveled. Okay. Now, if I say displacement, how much is the displacement? Sir, displacement means how much you have displaced actually. How much you have displaced. Sir, this is the initial point. This is the initial point. Sir, this is the final point. This is the final point. So we say, sir, distance between the initial point, final point, and initial point, that is the displacement. That is how much over here. Guys, tell me. Whole is 4 minus 3, and this distance is 1 meters. So in this case, displacement is, we say, sir, 1 meter. Distance in this case is 7 meters. We said displacement is 1 meters. Because displacement means how much you have displaced from the original point. Okay. And let's suppose, this is the question we have over here. If you have traveled from point A to point B, In this case, you have to tell me how much is the distance and displacement. We say, sir, in this case, displacement is 7 meters and displacement and distance both are, we say, sir, 7 meters in this. Both are 7 meters in this particular case. Is that clear, guys? Because over here, this is the shortest path and this is the actual path. Both are same. Both are same. Yes. Now, very important question that I want you guys to basically answer over here. Okay. This is a very good question. I want you guys to think about it and tell me the answer of this question. See. In this particular case, listen to me very carefully. We are given the position of an object is this one. Now you say, sir, what is this position? See. If I say, guys, see. If I say the car is, let's suppose, traveling from this point to this point, okay? Car has traveled from this point to this point. When it was at over here, x is equal to 0 meters, x is equal to 1 meters, x is equal to 2 meters, x is equal to, we say, sir, 3 meters. See. What I'm trying to say in this case is, when the car is at this point, its position is 2 meters, x is equal to 2. Where the object is actually, that is the position. When this car is at over here, we say its position is x is equal to 3 meters. And what is the displacement? Displacement means how much it has covered, That is final position, 3 minus 0, initial position. Final position minus initial position. Displacement is, we say, final position minus initial position. Finally, where the car is, initially where the car is. Now see, from this particular question, if the position of an object is, we say x is equal to t square plus 2t plus 4, then find its displacement in 4 seconds and in 4th second. It is a very good question and it is very important question. I want you guys to understand it very carefully and answer this particular question over. Guys, listen to me very carefully. In this case, let me solve this particular question. In this case, we say position of a particle is given. Sir, position of a particle is given, x is equal to, we say, sir, x is equal to, we say t square plus, we say, sir, 2t plus, we say 4. This is the position of the particle, okay? Car is moving according to this relation. Guys, if you are getting any sort of confusion at any point, sir, where does that come from? Where does this come from? I request you guys, I recommend you guys to remember it as of now. Because this is not the time to go into the detail, to tell you every single point. No, just remember it and keep on moving, because at the end of the day, you have to solve the problems. Okay. Now see. So we say x is equal to t square plus 2t plus 4. This is the position. This is how actually the car is moving. Now see, we have to find how much is the displacement in 4 seconds. Means, let's suppose I say we have got the car something like this, okay? And this car is moving and it has reached, let's suppose, this particular point over here. Okay. Now, my dear friends, listen to me very carefully. If I say at t is equal to 0, let's suppose at t is equal to 0, car is exactly over here. Let's find what is the position of the car, where the car is actually. What will you say? Sir, we say x is equal to, if we have to find the position, this is the position time relation. We say, sir, put t is equal to 0, this will be 0 square plus 2 into 0 plus, we say, sir, 4. So we say x is equal to 4 meters. Means, guys, when time was 0, we say the car is already at, how much the car is already at what position? We say, sir, xi is equal to 4 meters. It is already at xi is equal to 4 meters. Initial position is 4 meters. Means t is, sir, how is it possible? Maybe the car has traveled from this point, moving, and we started watching the time when the car is here. So we say that's why time is equal to 0, xi is equal to 4. Okay, now listen to me very carefully. In this particular case, let's suppose let's suppose I say when we say time t is equal to 4 seconds. Let's suppose we have to check at t is equal to 4 seconds, what is the position of the car? You say, sir, x is equal. See, in this particular equation, you will put 4 over here, 4. So it will be 4 square. Then we say 2 into 4. Then we say plus 4. So this will be 16 plus 8 plus 4. That is 28 meters. So means, guys, when it was t is equal to 4 seconds, we say final position of the car is, we say how much? That is 28 meters. Okay. Now you tell me, in this 4 seconds, how much is the displacement? Sir, we know displacement is simply, guys, see. We know displacement is simply, that is final position minus initial position. Sir, what is final position? That is 28 minus, what is initial position? That is 4. So how much? That is 24 meters. Means this distance is 24. Means this distance is, we say, sir, 24. Hey guys, is this crystalline clear? This is a very important question. I want you to tell me in the chats. Everybody, everyone means everyone in the chats. Is this crystalline clear? Is this crystalline clear? I want every one of you to tell me in the chats. Is this crystalline clear? 24 meters. Okay. Now we have to find the displacement in fourth second. Let me show you over here. We say, sir, second part. Yes. Good evening. I don't want your good evening, guys. I want your fire emojis with the answer, with yes or no. That's it. Okay. Now see. We say, sir, now displacement in fourth second. Displacement in fourth second. What does that mean? See. Let's suppose the car started from this point and it reached finally this particular point over here. It reached finally this point. Car started from this initial position and it has finally reached this particular position over here. Okay. Now see, guys. Sir, let's suppose at t is equal to 0, the car is exactly over here. At t is equal to 1 second, it is over here. T is equal to second, t is equal to 1, 2. We say, sir, 3, and this is t is equal to 4 over here. This is 3 and t is equal to 4. Now, guys, tell me one thing. We have to find over here how much is the displacement in fourth second. What does that mean? Guys, this is what we call the first second. This is what we call the first second because this is 1 second. This is what we call the second second. This is what we call the third second. And this is what we call the fourth second. This is the fourth second, means we have to find this displacement over here. We have to find this displacement over here. Now see, my dear friends, how do we exactly do it? Let's first find this distance. That is displacement in 3 seconds. And then we will find this whole distance. That is displacement in 4 seconds. Then we say displacement in 4 seconds minus displacement in 3 seconds. That will give us this displacement. Now tell me, guys, over here. See, when time t is equal to 3, let's find the position of the car. We say, sir, at t is equal to 3 seconds, let's find the position of the car. We say, sir, that is x is equal to, see, in this t, we have to put 3 square plus 2 into 3 plus 4. We say, sir, 3 square plus 2 into 3 plus, we say, sir, 4. So we say x will come out to be how much? This will come out to be 19 meters. It is 19. Okay. So means this distance is 19 meters. Okay. This position, when the car is over here, how much is the position? This distance is 19 meters. And already we have calculated, sir, at t is equal to 4 seconds, how much is the displacement? That is 28 meters. So this distance is 28. So now we have to find this. So can I say this distance would be, listen to me very carefully, that is 28 minus, we say, sir, 19 in this particular case. Tell me, guys. And that will come out to be 9 meters. So we say this is 9. So displacement in fourth second is how much? 19 meters. Guys, what we actually did is we calculated the position of the car at t is equal to 3. And we calculated the position of the car at t is equal to 4. Then we say this whole distance 28 minus this distance 19. Then we will get this distance, that is 9. Okay, tell me in the chats, bro. Tell me in the chats, is this clear? Is this crystalline clear to each and everyone? I want everyone to tell me in the chats, guys. Is this crystalline clear? Then only I'm moving forward. Else I'm canceling this live stream and I'll go and I'll sleep. Tell me in the chats, everybody. And make sure you like this session, okay? Make the like count 300 plus as soon as possible. Tell me, guys. Clear? Great, 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 great. Great. Now see. Let's talk about the velocity. Yes, kinematics 1D means motion in a straight line. Let's talk about the velocity. Sir, what is this velocity all about? Let me make you understand this particular concept. Let's suppose once again you started traveling from your house to your friend's house. That is, we say, sir, A. And we say, sir, you are moving from A to, we say, sir, B. From A to B. Let's suppose this is the point B. So you are moving from your house to your friend's house. Okay. Now in this case, let's suppose since this is the path that you are taking over here. Okay. Cool. Absolutely cool. Now, my dear friends, if I say, while you were moving from A point to B point, you covered, let's suppose, 100 meters. Okay. Yes, sir. And how much time you took while moving from A point to B point? Let's suppose you took 10 seconds. 100 meters in 10 seconds. Okay. Now, while you reach the point B, your friend is asking you, hey, tell me, bro, how much was your speed? What was your speed? What was your velocity? With what velocity you were exactly moving? How faster you were moving? You say, sir, if I have to find the velocity over here, okay, how faster you are moving, what will you say? You'll say, sir, we say total displacement traveled upon, we say, sir, total time taken. Total displacement traveled upon total time taken. Yes, sir. Sir, you can say it something like this also, sir. Total displacement traveled from this point to this point. We say, sir, let's suppose that is delta S, or that is change in distance. And total time taken is, let's suppose, delta T. Okay. In mathematics, how do we write? Delta S divided by delta T. Cool. Now, how much is the delta S over here? That is the displacement from this point to this point. How much that is given? 100 meters. So I'll just write over here, this is 100. And divided by, I say over here, this is 10. Now you tell me one thing, sir, this will come out to be 10 meter per second. This comes out to be, we say, sir, 10 meter per second. What does this 10 meter per second actually mean? This is what we call the velocity. Or we say how faster you are moving. Okay. Let's suppose I say it is mentioned over here. Listen to me very carefully. It is mentioned over here 10 meter per second. What does that mean? Every second you were covering 10 meters. If I say it is mentioned over here 20 meter per second, what is that? Every second you were covering 20 meters. Means you are moving more faster. If I say, sir, 30 meter per second, what does that mean? Sir, you are moving more faster. Every second you were covering 30 meters. And if I say, let's suppose you have got 100 meter per second, what does that mean? You are moving more faster. Or we say, sir, 100 kilometer per hour. What does that mean? Sir, every hour you are covering 100 kilometers. Okay, this is the meaning over here. Now, my dear friends, in this particular case, so this is what we call the velocity. Now you tell me one thing. Sir, this velocity which you actually got, this is the velocity in general. This is the velocity in general from A point to B point. This is not the velocity which tells you the velocity at any particular point. How much is the velocity at this point, sir? How much is the velocity at this point, sir? No, 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 no. So this velocity is what we call this. This is called average velocity. This is called average velocity. And how do we write this average velocity, sir? VAVG. Simply, it is total displacement traveled, that is delta S, divided by, we say, sir, delta T. Total displacement traveled upon total time taken. This is the average velocity which I want you guys to keep in your mind. This is the average velocity over here. That is total displacement traveled upon total time taken. Now, my dear friends, in this particular case, if I ask you to tell me how much is the velocity at any particular instant, sir, you are saying, sir, from A point to B point, my velocity was 10 meters per second. But tell me, sir, when I was at this particular point, how much is the velocity over here? You say, sir, that is what we call the instantaneous velocity. We say, sir, it is the velocity. It is the velocity at any particular instant. It is the velocity at any particular instant. Velocity at any particular instant is what we call the instantaneous velocity. And how do we exactly represent it? Sir, VINS is equal to, we say, sir, ds divided by dt. Over there, it was delta S by delta T, but instantaneous means ds by dt. Small change in displacement upon small change. Hey guys, tell me in the chats, is this clear? Is this clear? Is this clear to each and everyone? Is this clear? All the people out there, guys. Is this clear? Okay. Is this clear, guys? All the people. See, one more important point I just want to tell you. A slope of xt time graph, velocity time graph, we'll see later on while we reach the slopes. As of now, whatever I said, tell me that only. Is this clear? Okay. Now listen to me very carefully over here. Listen to me very carefully. Let's suppose we have got a car. Let's suppose we have got a car. And this car is moving in the forward direction. And its velocity is, we say, sir, 20 meters per second. This is the velocity of the car, that is 20 meters. If it is moving towards right, we consider its velocity as positive. Remember from now onwards, this is a sign convention. If the car is moving towards right, we consider its velocity as positive. Now, if I say I have got the car over here, and this car is actually moving towards, we say, sir, left. With what velocity? We say, sir, 40 meters per second. So in this case, we say, sir, its velocity is minus 40 meters per second. So if the car is moving towards left, we consider its velocity as negative. And if the car is moving towards right, we consider its velocity as positive. As simple as that. As simple as that. Now. This is one type of question which can be asked in your NEET exam, because different times this question have been asked. Sir, what does this question say? Listen to me very carefully. A car travels 2/5 of the total distance. A car travels 2/5 of the total distance. Let's suppose the car travels from this point to this point. From this point to this point. Let's suppose the car is traveling from this point to this point. It says that it is traveling 2/5 of the total distance. Let's suppose total distance over here is d. So it is traveling 2/5d. 2/5 of the total distance with speed v1. With v1. It is traveling 2/5 of the distance with v1. Means this distance it is covering with what speed? That is with v1. That is with v1. Okay. And Remaining 3 by 5d distance it is covering with V2. We say, sir, 3 divided by 5d, it is covering with V2. This distance, 3 by 5d, it is covering with V2. In this case, we have to find the average velocity. Guys, whenever you see the question of this sort, there is only one trick. Listen to me very carefully. Since it is asking you to find the average velocity, because many times this question have been asked, since it is asking you to find the average velocity, in case of average velocity, you directly remember one formula, no other formula. What is that? We say, sir, average velocity means simply that is total displacement traveled upon total time taken. As simple as that. Delta x by delta t. Delta s by delta t. Okay. This is the formula which will help you to solve every question when it comes to the average velocity. Now, in this case, could you please tell me how much is the total distance traveled? Sir, this is the total displacement traveled. 2 by 5d plus 3 by 5d. This displacement plus this one. Okay. So that will be, sir, 2 divided by 5d plus, we say, sir, 3 divided by 5d. This is the total displacement. Divided by. Listen to me very carefully. Divided by. Some people are writing it shortcut over here. That shortcut comes actually from this formula only. But I am telling you the main logic, because there are many different parts which comes out of this formula. That's why I am telling you to remember the general formula only. Whatever the case you have afterwards, you can use this formula. Now see, we say, sir, 2 by 5d plus 3 by 5d. This is the total distance traveled. And divided by total time taken. Can you tell me how much is the time over here? Let's suppose the time is t1. Can you find that time t1 over here? Sir, we say velocity is equal to displacement upon time. So time is equal to displacement upon velocity. And how much is the displacement over here? That is 2 by 5d. How much is the velocity over here? That is v1. So if I write over here, this is t1 plus t2. So can I write it further something like this, sir? This will be 2 by 5d. 2 by 5d. Then we say plus 3 by 5d upon. When I have to write this t1. T1 is displacement upon velocity. Displacement is how much? 2d by 5. 2d by 5. So we say, sir, 2d divided by 5 v1. Why do I write v1? Because displacement upon velocity. Then we say plus 3d by 5 v2. 3d by 5 v2. 3d by 5 v2. Okay. And then we say is equal to over here. Is equal to over here. If you add this with this, 2 by 5d plus 3 by 5d, it will be d upon. And over here, this will be 2d by 5v1 plus 3d by 5v2 directly over here. 2d by 5v1 plus 3d by 5v2. dd will get cancelled over here. See, this d, this d, this d, this d, they will get cancelled out. And finally, what will come out to be the final answer? That is 5 times of v1, v2 divided by 2 times of v1 plus 3 times of. This is the answer. See, the main point is, whenever someone gives you the question of this sort, you will have to use this particular formula. That is total displacement traveled upon total time taken. Is that clear? Tell me in the chats, everyone, if this is clear to each and everyone. Tell me in the chats, guys. Tell me in the chats, guys. Is this clear to each and everyone? Tell me in the chats. Everyone means everyone. Everyone means everyone. All the people out there. Is this crystalline clear? Is this crystalline clear, guys? Is this crystalline clear over here? And I want you guys to like this session, guys. How many times do I have to tell you? Make it 350 plus. Make it 350 plus as soon as possible. Okay. Clear. Great. Let's move on to the next question. This is the next question which I want you guys to exactly solve from your end only. The question which I want you guys to solve. What does this question actually say? Listen to me very carefully. Guys, sir, explain once again, sir. I request you to please watch it later, okay? Because when we end this live stream afterwards, you can watch it at 2x, okay? Because 99% of the students actually understood. It is simple. It is simple. You say total distance traveled upon total time taken. Total distance is this distance plus this distance. Total time is how much time it took in this journey. That is T1. How much time it took in this journey, T2. T1, how can you find? That is distance upon velocity. This distance upon velocity. T2, how can you find? This distance upon this velocity. And then you have to put those values over here. Then you have to put those values over here. Okay. Now listen to me very carefully. If the position of an object is x is equal to, if the position of an object is x is equal to t square plus 4t plus 5. This is given as the position of the object. The car is moving according to this relation, okay? Now, my dear friends, then find the instant when velocity becomes 0. Let's suppose, see, what I'm trying to say in this case is, let's suppose you have got a car over here. Okay? And this car is, let's suppose, moving. Okay? It says that if it is moving according to this relation, okay? Now, my dear friends, it is saying that if the car is moving, you have to tell me, find the instant when velocity becomes 0. You have to tell me that time. What is the value of the time when the velocity of the car is 0? We have to find the instant. Instant means time. We have to find the time when velocity of the car becomes 0 exactly over here. Okay. Now listen to me very carefully. What is given position? X is equal to, we say, sir, t square minus 4t plus, we say, sir, 5. This is the position of the car which is given. Sir, from the position, we have to find the velocity. Let's find velocity. If x is given and you have to find the velocity, how do you find? Sir. We know once as we say, sir, velocity is dx divided by dt. Velocity is dx by dt. That is differentiation of this. So how do we differentiate it? The differentiation of t square is, we say, sir, 2t. Then differentiation of 4t is, we say, sir, 4. And differentiation of 5 is 0. Now, guys, this is the velocity. In the question, it says that find the instant when velocity becomes 0. Means put the value of velocity is equal to 0 over here. Because it is saying that velocity is 0. So, my dear friends, if I say 2t minus 4 is the velocity and it is equal to 0, can you find the time here? So, we say, sir, 2t is equal to 4. T is equal to 4 by 2. So, t is equal to 2 seconds. So, we say in this case, sir, t is coming out to be how much? 2 seconds. So, means when you put the value of velocity equal to 0, then only you got the time is equal to 2 seconds. So, I can write over here at t is equal to 2 seconds. We say velocity of the car is 0. Velocity of the car is 0, body will come to rest. Picture is not clear over here. Isn't the picture clear? I think everything is visible over here. Isn't the picture clear, guys? Everyone means everyone. Tell me. So when time t is equal to 2 seconds, we say velocity of the car is 0. Now, second part of the question is, and also you have to find the displacement. You have to find the displacement when object comes to rest. You have to tell me how much it has displaced. Guys, let's suppose this car is exactly moving. Let's suppose this car is exactly moving. Okay. So we know, sir, you calculated recently when t is equal to 2 seconds, sir, velocity of the car is 0. It has come to rest. Now, guys, you have to tell me how much is this displacement which it has covered in this entire journey. We have to cover this distance, this displacement. Okay. So when car comes to rest, how much is that displacement covered? Now, my dear friends, you tell me one thing. over here. if I say, listen to me very carefully. If I say over here, what is the position time relation that is given? Sir, position time relation is given as x is equal to t square. Listen to me, as we say, sir, x is equal to t square minus 4t, we say, sir, plus 5. X is equal to minus 4, t square minus 4t plus 5. If I say, listen to me very carefully, at we say, sir, t is equal to 2 seconds. At t is equal to 2 seconds. Can you tell me, sir, how much, what is the position? What is the position? We say, sir, x is equal to, we say, sir, 2 square minus 4 into 2 plus, we say, sir, 5. And this will be simply 4 minus 8 plus 5. So this will be exactly 1 meter. So it is actually find the position, find the position when object comes to rest. You have to tell me what is the position over here when object comes to rest. Means how much, what is the position? Means x is equal to 1 meter. X is equal to 1 meters. So means, guys, at t is equal to 2 seconds, velocity is 0. Now, at t is equal to 2 seconds, how much is the position? We say, sir, position of the car is 1 meter. Is this clear? Is this clear, guys? Tell me in the chats, is this clear to each and everyone? Is this clear to each and everyone? Everyone means everyone, guys. Now, one more type of question on the same pattern. This is the question that you have on the screen. I want you guys to answer this particular question. I hope you are liking the session. Guys, tell me in the chats, are you liking the session? Is every concept getting crystal and clear? Is every concept getting crystal and clear over here? This is the next question. X is equal to t square plus 4t plus 10. Find time when object comes to rest. Guys, in this case, we'll have to use the same. We'll have to use the same formula. Tell me. See. Sir, in this case, x is equal to, we say, sir, t square plus 4t plus 10. This is the position. We have to find the velocity. Sir, velocity is simply dx by dt, differentiation of this. And if we differentiate this term, so we say differentiation of t square is how much? We say, sir, 2t plus. Differentiation of 4t is how much? We say, sir, 4. And differentiation of 10 is, we say, 0. It says that find time when velocity of the body is 0. So we say put v is equal to 0 over here. So we say 2t plus 4 is equal to 0. So t is equal to 2 seconds in this. T is equal to 2 seconds in this case also. Sorry. So we say in this case 2t is equal to 4 minus 4. T is equal to minus 2. Guys, can time be negative? Tell me. Sir, time can never be negative. Time can't be. If time cannot be negative, means object will never come to rest, because we got the time as negative. So object never comes to rest. Object never comes to rest in this particular case. Object will never come to rest in this particular case. Means if this car is moving something like this, so it will keep on moving forever. It will never come to rest. Why? Because we put the velocity of the value as 0. Then we got the time as minus 2 seconds. Means object in this case will never come to rest. Oh no, somebody is saying, oh no. Okay, I hope you got it. Is that clear, guys? Tell me in the chats. Is this clear? Let's move on to the concept of acceleration. What is acceleration? Acceleration means how fast car is changing its velocity. See, you are sitting inside your car, okay? Your friend is driving the car, okay? and you are telling him, hey bro, accelerate the car, we want to run, we want to move very fast. So what does he actually do? He puts his foot on the accelerator and keep on pressing it. So because of that, what happens? We say, sir, speed of the car keeps on changing, increasing, 10, 30, 40, 50, 60, 100, 160, and directly to the heavens. Okay. So this is how actually happens. Acceleration means you are changing the velocity. The change in velocity can be increase in velocity. It can be decrease in velocity. The change in velocity can be increase. It can be decrease. Okay. So means, my dear friends, from now onwards, you say, sir, when it comes to the acceleration, you say how fast velocity is changing. How fast velocity is changing. Like, let's suppose we have got a car over here. It is moving something like this. Over here, when the car is at this point at time t is equal to 0, when the car is at over here at t is equal to 0, we say its velocity is 0. Its velocity is 0. After some time, it started moving. After some time, when the time t is equal to 1 seconds, we saw that velocity of the car came out to be 10 meter per second. Now it started moving with a good speed. Okay. Then after some time, at t is equal to 3 seconds, we saw that velocity of the car is 18 meter per second. It came out to be 18 meter per second. And after some time, we saw that when t is equal to 4 seconds, velocity of the car came out to be 24 meter per second. It is increasing something like this. So can I say in this particular case, we say, sir, here, car is accelerating. Why? Because velocity of the car is changing, means the car is accelerating. Okay. Now, if you have to find this acceleration, let's suppose we will find the acceleration during this interval. Okay. Let's find the acceleration over here. You say, sir, when it comes to the acceleration, it is simply change in velocity. It is change in velocity upon, we say, sir, change in time. Okay, simply, sir, change in velocity upon change in time. So we can write it something like this, delta V divided by delta T. Now, if I say how much is the change in velocity from this point to this point, sir, we can also write it, this is final velocity minus initial velocity divided by delta T, that is time. Now, guys, tell me, sir, initial velocity is 0, final velocity is 10. You say, sir, it is 10 minus 0 divided by time. Time is how much? That is 1 second. So it is, so acceleration in this case came out to be, sir, it is 1 meter per second square. This is the unit of acceleration. 1 meter per second square came out to be the acceleration. Now, what does it say? It says that every second, it is 1 meter per second per second. It means every second, 1 meter per second velocity is increasing. If it was 10 meter per second, then we say every second 10 meter per second velocity is increasing. Leave this, bro. Directly you say, sir, acceleration in this case came out to be 1 meter per second square. Now listen to me very carefully. Listen to me very carefully over here, my dear friends. Let's talk about, if I say, listen to me very carefully. What is acceleration? Acceleration is change in velocity. Means if velocity is increasing, body is accelerating. If velocity is decreasing, body is accelerating. Both are the cases of acceleration. Now see, what is the meaning of, we say, sir, positive acceleration? Let me give you the feel of positive acceleration. Positive acceleration means, acceleration is positive means the direction of acceleration is forward. The direction of acceleration is forward. Means acceleration is forward. Sir, if you say positive acceleration, that means acceleration is forward. Does that mean car is also moving in the forward directions? No. I'll write over here. Does not mean car is moving forward. It does not mean car is moving forward. But if I say velocity is positive, guys, If I say velocity is positive, that means car is moving forward, car is moving towards the right. If I say velocity is negative, that means car is moving towards the left. But if I say acceleration is positive, it means acceleration is forward. But that does not mean car is moving forward or object is moving. Hey guys, is this clear? Tell me in the chats, is this clear? Everyone, tell me in the chats, is this clear? Is this clear? In the chats, everyone. Okay. Let's suppose we have got a car over here. Let's suppose we have got a car over here. This car is moving with a velocity of, let's suppose we say, sir, 20 meter per second. Okay. And we say in this case, let's suppose this car is moving with, let's suppose, 30 meter per second. And time is, we say, sir, delta t in this case is 1 second. And during this journey, velocity of the car is changing. If you have to find the acceleration, you say simply, sir, in this case, we say acceleration is change in velocity upon change in time. How much is the change in velocity? That is 30 minus 20, that is 10. Divided by 1, that is 10 meter per second. This is the acceleration. Let's talk about the negative acceleration. Let's talk about the negative acceleration. Sir, when negative acceleration, I'll just write over here, negative acceleration. Sir, what does negative acceleration mean? Listen to me very carefully. Negative acceleration means acceleration is negative. It means acceleration is backward. Sir, does it mean car is moving in the backward direction? No, not at all, not at all. Now see, if I say, let's suppose in this particular case, sir, this car is moving with a velocity of, let's suppose, 20 meter per second. Okay. And over here, it is moving with a speed of, let's suppose, 10 meter per second. If I say in this case, tell me the acceleration. You say, sir, final velocity is 10 minus initial velocity is 20 divided by, let's suppose, time in this case is 1 second. That is 1 second. So how much it came out to be? 10 minus 20, that is minus 10 meter per second. Okay. This is what we call the negative acceleration. Value of acceleration, if it comes out to be negative, no, don't say decreasing in speed. No. Decreasing in speed is something else, bro. We say acceleration in this case came out to be negative. Acceleration in this case came out to be negative. Acceleration means backward acceleration. Negative acceleration means backward acceleration. Okay. Is that clear? Whatever I say over here, just keep on remembering that only. Is this clear, guys? Okay. When acceleration is negative, means acceleration is in the backward direction. When acceleration is positive, means acceleration is in the forward direction. Retardation is something else. I will tell you, retardation is decreasing in speed. After some time, I will tell you. Now see, sir, what is average? We know, sir, we got to know positive acceleration, negative acceleration. Let's talk about now average acceleration, sir. Let's suppose if you are moving from A point to, let's suppose you are moving to B point, from A to B. Okay. From A to B, if I say, sir, change in velocity is delta V and change in time is, let's suppose, delta T. It is general. From A to B, how much is the acceleration? If I ask you, you say, sir, from A to B, acceleration is delta V divided by delta T. And this is what we call the average acceleration. Okay. Acceleration in general from A to B. But if I tell you, listen to me very carefully. Let's suppose this is point A and let's suppose this is point B. This is point A and this is. And in this case, if I tell you how much is the acceleration, at any particular instant. How much is the acceleration at any particular instant? Sir, that acceleration is dv divided by dt. And that acceleration is what we say instantaneous acceleration. Average acceleration means acceleration between the 2 points. Instantaneous acceleration means acceleration at a particular point. Is that clear, guys? Is that clear? Tell me in the chats, bro. Is this clear? Is this clear? Okay. Let's talk about, I want to know from everyone if this is clear, please, please. If this is crystalline clear, I want to know from everyone. Everyone means everyone. Those who are only watching and writing, making the notes, learning properly, I want those students also to write in the chats if this is crystalline clear. Then only I'm moving forward. Otherwise, no, I will not move forward. That's for sure. Tell me. And make sure you hit the like button. That's mandatory. All the people out there. Great. Great. Now see, let's talk about the retardation. Let's talk about the retardation. See, I'll make you understand what is retardation. I'll make you understand what is retardation. See. Let's suppose this retardation, I'll write first point, negative acceleration does not mean retardation. Negative acceleration does not mean retardation. First point, keep this in your mind. Negative acceleration means acceleration is backward. That's it. Value of acceleration is negative. That's it. So then what is retardation? We say retardation, we say means slow down, slowing down. Means if the speed of the car is decreasing, listen, then we say it is retardation. Sir, please, we want the examples. Let me make you understand with an example. Let's suppose you have got a car over here. This is the car, okay? And this car is, let's suppose, moving with 20 meter per second, okay? And let's suppose we have got this car over here, and this car reached over here and it is moving with 10 meter per second, okay? And in this case, let's suppose time t is equal to 1 second. And in this case, you have to tell me the acceleration. Guys. Here, speed is 20 meter per second initially, and speed is 10 meter per second finally. We say, sir, speed is decreasing over here. The acceleration which came out to be in this particular case is, we say, sir, over here, acceleration is simply, listen to me very carefully. Acceleration is simply, in this case, final velocity is 10, initial velocity is 20, divided by 1, so it is minus 10 meter per second square. So this acceleration in this case is retardation. Sir, over here it came out to be negative. Yes, it can be negative, it cannot be negative. Sir, give another example. Let me give you another. See. Let me give you another. Let's suppose we have got a car over here. This is the car, okay? And this car is moving with a speed of, let's suppose, 20 meter per second over here. But 20 meter per second in the backward direction. And after some time, let's suppose this car reached over here and it is moving with, let's suppose, 10 meter per second. In this case also, could you please tell me, is the velocity of the car increasing or decreasing? Say, sir, velocity of the car in this case is decreasing. So, my dear friends, if I say acceleration over here, we say, sir, that will be change in velocity. That is final velocity minus initial velocity. Tell me. I'll write over here final minus initial divided by delta t. Let's suppose t is equal to 1 second. Tell me, sir, when the car is moving, towards left, we take its velocity as negative. So this is minus 20, this is minus 10. So this will be minus 10 final velocity. Then we say minus of initial velocity, minus of v initial. Initial velocity is minus 20. We say, sir, minus 20. Divided by time over here is 1 second. Minus into minus becomes plus. So plus 20 minus 10, it will become Sir, 10 meter per second square. 10 meter per second square. So this is the velocity of the car. This is the velocity of the car. Okay, this is the velocity, sorry, this is the acceleration of the car. And we call this acceleration and retardation. This is what we call the retardation. Why? Because over here, we say, sir, car is slowing down. And this retardation came out to be positive. This is positive. See, the value of this is positive. Value of this is positive. Is this clear, guys? Hey, how is it? Is it 30 meter per second square? It is 10 plus 20. Minus 10 plus 20. That is minus 10 only. That is plus 10 only. Plus 10 meter per second square. So we say it came out to be positive, means in this case, retardation is positive. In this case, retardation is positive. So retardation, that's what I told you over here. Negative acceleration does not mean retardation. But we say slowing down means retardation. Slowing down means retardation. Yes, JEE students can watch this. Okay. Now listen to me very carefully. Listen to me very carefully. The important format. One more point I just want to tell you. Guys, as acceleration in terms of displacement. Acceleration displacement equation. See. Sir, when it comes to the acceleration, we say, sir, acceleration is dv divided by dt. Hey, I hope this is clear till over. Hey, I hope this is clear. I'm putting my maximum efforts to make you guys understand. Now see, we say acceleration is dv divided by dt. See, so can I just do one thing over here? We can multiply with ds, we can divide with ds. That is displacement. Multiply with ds and divide with ds. Now, we can say, sir, interchange. See, what I want you guys to do is, we know, sir, acceleration is dv divided by dt. I want you guys to multiply this ds divided with the ds. Okay. Now, you interchange the position of this and this. You interchange it. So I can write acceleration is dv divided by ds multiplied by, we say, sir, ds divided by dt. Sir, what is the value of ds divided by dt? We know, sir, rate of change of displacement with time is velocity. So instead of this, I can write velocity. So acceleration will come out to be v dv divided by ds. V dv divided by ds. So this is what we call the acceleration over here. So this is the acceleration in terms of displacement. This is not the acceleration in terms of time. Okay, this is the acceleration in terms of displacement. Acceleration is v dv by ds. Acceleration is v dv by ds. Okay. Now remember this format. I want you guys to remember this particular format. What is that? See. Listen to me very, very, very carefully. Let's suppose, guys, let's suppose you are given the displacement. Okay. And this is, let's suppose, velocity. This is, let's suppose, velocity. And this is, let's suppose, acceleration. You have got displacement, you have got velocity, and you have got acceleration. My simple question to you guys is, if you have to find the velocity and if displacement is given, what is the formula you will use? You will use, sir, B is equal to ds divided by dt. Sir, this is the formula that you will be using in order to find the velocity if displacement is given. If displacement is given, you have to find the velocity, you will differentiate. Okay. Now, if velocity is given and you have to find the displacement, what will you do? Let me make you understand over here. Guys, as we say, sir, V is equal to ds divided by dt. I want you guys to take this dt and place it over here. So we say it is V dt is equal to, we say, sir, ds. Now I want you guys to integrate. If you integrate this, sir, integration of ds will be what? It will be, sir, total displacement s, and it will be integration v dt. So s is equal to integration of v dt. Means if velocity is given, and you are find the displacement, you have to do the integration. If displacement is given, you are supposed to find the velocity, you'll do the differentiation. But in the reverse case, what you are supposed to do, S is equal to integration of V. If velocity is given and displacement, you are supposed to find out integration of V dt. Similarly, over here, if velocity is given, you have to find acceleration. You say acceleration is dv divided by dt. But if acceleration is given and you have to find the velocity, you will say, sir, acceleration is dv divided by dt. Now, in this case, take this dt and multiply over here. See, how will I exactly do it? How will I exactly do it? So we say a dt is equal to, we say, sir, dv. So dv is equal to a dt. Now integrate. Integration of dv. dv means change in velocity. Small change in velocity. dv means small change in velocity. So small change in velocity integration will give you large change in velocity, delta v. So it is integration of a dt. So means from now onwards, if acceleration is given and you have to find the velocity, what will you do? You will integrate. So that is delta v is equal to integration of a dt. This is the format which you guys need to remember, because this will help us to solve all the questions. These are actually the equations of. Okay. Is this clear, guys? Tell me in the chats if this is clear. Tell me in the chats, everyone means everyone. Tell me in the chats if this is clear, guys. Everyone means everyone. And make sure you hit the like button, all the people out there. Great. Now, let's move on to some questions. Let's move on to some questions. Object is moving such that its position changes as a function of time, x is equal to c. In this case, we are given position x is equal to, we say, sir, alpha t square. Find initial, okay, x is equal to alpha t square, then we say beta t plus, we say, sir, gamma. This is the question that we are given exactly over. Okay. Let's suppose we have got a car over here. This is a car which is exactly moving according to this relation. It is moving according to this relation. Alpha t square plus beta t plus gamma. In this case, we have to find the initial velocity, initial acceleration, and initial position. What does initial velocity mean? Initial velocity means the velocity at time t is equal to 0. Now, let's first find the velocity. Let's first find the velocity. Sir, velocity is simply dx divided by dt. Differentiation of this above term. So that is, what is the differentiation of this? Take this 2 down. This will be 2 alpha t plus, we say, sir, beta. And alpha, beta, and gamma are the constants. So differentiation of gamma will be 0. So this is, we say, sir, the velocity. Now at t is equal to 0, can you tell me what is the value of velocity? You say, sir, velocity is, put the value of t is equal to 0. In this case, we say, sir, 2 alpha into 0. Then we say, sir, plus beta. So velocity will come out to be, sir, beta. So this is what we call the initial velocity. I want you guys to keep this in a box. This is what we call the initial velocity. The velocity at t is equal to 0. Now, can you find the acceleration? Now, we say, sir, acceleration. Sir, acceleration will be simply, sir, that is dv divided by dt. That is differentiation of velocity. Velocity is this one, 2 alpha t plus beta. So differentiation of beta is 0. So we say then differentiation of 2 alpha t will be simply 2 alpha. This is what we call the acceleration. And Guys, in this case, see, 2 is constant, alpha is constant, means in this case acceleration is constant. So this is also considered to be as initial acceleration. This can be considered as initial because this is constant. Whatever is the acceleration before will be afterwards. Let's find the initial displacement, initial position. Then we have to find the initial position. Okay. Initial position. See, if I take the this position time relation, so we say, sir, x is equal to, see, initial position means at t is equal to 0. What is the position? Just put the value of t is equal to 0 over here. This will be 0. This will be 0. B times 0 is 0. And this will be gamma. So it will be. So this is what we call the initial position. This is initial velocity. And this is, we say, sir, initial acceleration. Is this clear? Is this clear? Is this clear? This is your homework that I am giving. This is your homework that I am giving over here. I want you guys to exactly. Okay. This is the homework that you have exactly over here. If v is equal to kx, then find acceleration at x is equal to 2. Okay. 2 alpha. This 2 alpha comes, my dear friend, if you have got the velocity, from velocity you will have to find the acceleration. So if you have got this velocity, you have to find the acceleration. So you will differentiate it once again. So differentiation of 2 alpha t is how much? 2 alpha only. And differentiation of beta is 0. So that's why this will be the acceleration. Just a second. Okay. Now see, let's move. Now we have got this particular question over here. I want you guys to exactly solve this particular question in this particular case. V is equal to 3t square, find the displacement in 2 seconds. Okay. See, velocity in this case is given, that is 3t square. Okay. And you have to find the displacement in this. Come on to this particular format. Sir, if velocity is given and you have to find the displacement, which formula you will be using? This one. S is equal to integration of v dt. So same formula I'll be using. S is equal to, I say, sir, integration of v dt. Now what is the value of integration over here? We say, sir, S is equal to integration of velocity, that is 3t square into dt, because velocity is given as 3t. And we have to find the displacement in 2 seconds. So you'll put the limits from 0 to 2 over here. Okay, now it is simple, the question of integration. So take this 3 out. It will be then integration of, then we say t square. It will be t cube divided by 3. Because integration of t square will be how much? Integration of t square will be how much? Integration of t square will be how much? T cube divided by 3. Because if you have to integrate t square, it will be simply, sir, t raised power 2 plus 1 divided by 2 plus 1. Power plus 1 upon power plus 1. So we say simply it will be t cube divided by 3. And in this case, the limits are from 0 to 2. 0 to 2. So I can further write it. So this will be simply over here, this and this will cancel. 2 cube is, we say, sir, 8 over here. Is this clear, guys? Tell me in the chats. Okay, this 3 and 3 will get cancelled. Then you put the upper limit over here. That is 2 cube is 8. 2 cube minus 0 cube, it will be 8. Okay. Now you have got this question over here. This is also which I am giving you the homework. This is also which I am giving you the homework. This is also which I am giving you the homework in this case. A particle undergoes a one-dimensional motion. A particle undergoes one-dimensional motion such that its velocity is v is equal to bx raised power 2n. Simple. Where this is not b, this is beta. Where beta x raised power minus 2n. Where beta and n are the constants and x is the position of a particle, the acceleration of the particle is given by, you have to find the acceleration. See. In this case, velocity is given and you have to find the acceleration. How will you find the acceleration? Acceleration is simply that is dv divided by dt. You have to differentiate this term, okay, over here, and you have to find the acceleration in this case. Okay. No. This is the acceleration in terms of x. The acceleration of a particle in terms of x. No. You will have to use that another equation. Acceleration in terms of displacement. I hope you got that. A is equal to v dv by dx. This is the velocity over here in terms of x, and you have to find the acceleration. Yes, we have to use this equation. If in this case we say acceleration is v dv divided by dx, don't use dv by dt. Why? Because in this case velocity is given in terms of x. Okay. This is your homework, guys. One more question over here. Let's solve this particular question. And before me, I want you guys to exactly solve this question on the screen. If velocity of a particle is v is equal to at plus bt square, velocity of the particle is at plus bt square, where a and b are constants, then the distance traveled between 1 second and 2 seconds is. See, how do we exactly solve this question? See, sir, in this particular case, velocity is given. Let me zoom it more. In this particular case, we say, sir, velocity is given. We say, sir, velocity is at plus bt square. This is the velocity which is given in the question. Okay. And in this case, we are supposed to find, see, velocity is given. I'll mention it. Velocity is given. We are supposed to find the distance traveled between 1 second and 2 seconds. Guys, if velocity is given and you have to find the displacement, which formula will you be using? We say, sir, we recently studied. If velocity is given and we have to find the displacement, we say, sir, S is equal to, listen to me very carefully, integration of v dt. And if displacement is given and you have to find the velocity, we say v is equal to ds by dt. We'll do the integration. Now, my dear friends, in this case, can I say S is equal to? We say integration of. Instead of velocity, can we put this equation? So we say, sir, at plus we say, sir, bt square. At plus bt square. And its integration, that is dt. Now the question is, it is saying from 1 second to 2 seconds. 1 second to 2 seconds. So we will put the limits from 1 second to 2 seconds. We will put the limits from 1 second to 2 seconds over here. Now do the integration and get the displacement or the distance. S is equal to integration of this at. It will be simply, sir, it will be at square divided by 2. Why? Because integration of t is t square by 2. Then we say, sir, plus. Over here. We say, sir, this is b. Then we have this b. B is constant. Sir, integration of t square. We say, sir, it will be t cube divided by 3. And we say, sir, limits are from, we say, sir, 1 to 2. Limits are from 1 to 2. Now, after solving this, putting the value of t as 2 first, putting the value of t as 1, okay, upper limit, lower limit, after solving from this. So finally solve this. Finally, the answer will come out to be, we say, sir, 3 divided by 2a plus 7 divided by, we say, sir, 3 by 2a plus 7 by 3b. There is a bit more calculation over here that you will do from your end. I told you the concept, 3 by 2a plus 7 by 3b. Option number 3 is. Guys, tell me in the chats, please and please, is this crystalline clear? Is this crystalline clear? Is this crystalline clear? Is this crystalline clear? Tell me. I want everyone to tell me in the chats. I want everyone. Everyone means everyone. In the Dream Crash Course batch, it is not possible to teach like this. Teach like this means on this, like teaching on iPad like this, seeing the screen backwards, standing, because over there you will have the different setup inside Unacademy. That's the reason. No, not the. Wait for some time, bro. We'll finish this chapter and we'll go. After that, we'll do the dinner. Okay. Now listen to me very carefully. Now we have got the question over here. Listen to me very carefully. A particle moves along a straight line such that its displacement at any time is given by s is equal t cube minus t 60 square plus 3t plus 4 meter. The velocity when the acceleration is 0. The velocity when the acceleration is 0. See. The question says that the displacement of the particle is given by, listen to me very carefully, s is equal to, we say, sir, t cube minus 60 square, okay. Then we say plus 3t plus, we say, sir, 4. S is equal to t cube minus 60 square plus 3t plus 4. This is a displacement. If I ask you to tell me the velocity from this one, you say, sir, velocity is simply ds divided by dt. Okay. Displacement, differentiation of displacement. So that will be, for t cube, it is 3t square. What is the differentiation of t cube? That is 3t square. Then we say minus. What is the differentiation of 60 square? That is 2 6s 12t. Then what is the differentiation of 3t? We say, sir, plus it is 3. Plus it is. Okay. Now, my dear friends, listen to me very carefully. Listen to me very carefully. This came out to be the velocity. Can you tell me, sir, what is the acceleration? Acceleration is simply dv divided by dt. Because if you differentiate velocity, once again, you will get the acceleration. Means a differentiation of this. What is the differentiation of 3t? That is 3 into 2 is 6t. Differentiation of 3t square is 60. What is the differentiation of 12t? It is minus 12. And what is the differentiation of 3? It is 0. It is 0. Okay. Now, my dear friends, I want you guys put acceleration is equal to 0. I want you guys to put the value of acceleration as 0. So when you put the value of acceleration as 0, that is 60 minus 12 is equal to 0. So we say 6t is equal to 12. T is equal to, we say, sir, 2 seconds. So means at t is equal to 2 seconds, acceleration is 0. I can say it something like that also. Now, can you tell me, sir, when acceleration is 0, we say, sir, time is 2 seconds. When acceleration is 0, we say time is 2 seconds. Now, let's find the velocity at, we say, t is equal to 2 seconds. Let's find the velocity at t is equal to 2 seconds. Guys, can you tell me what is the value of velocity at t is equal to 2 seconds? You will simply say, sir, see, we have got this as velocity. Put the value of t is equal to 2 over here and get the velocity. Now, we can say, sir, velocity over here is, we say, that is 3t square minus 12t plus 3 minus 12t say sir plus 3. This is the velocity. Now, if you put the value of velocity time as 2, this will be 3 into we say sir 2 square minus 12 into we say sir 2, we say sir plus 3 plus 3. Now tell me, sir, this is we say 3 into 4 is we say sir 12. 12 minus 24 plus 3, it will come out to be minus 9 meter per minus 9 meter. So guys, what I'm trying to say is that when time is equal to 2 seconds, at that point acceleration is 0. At that time velocity is 9 seconds. This is what we were supposed to calculate. This is what we were supposed to calculate. Sir, find the velocity when acceleration is 0. I am saying that, sir, when acceleration is 0, time is 2 seconds. Okay, time is 2 seconds. And at this time only, we got the value of velocity that came out to be minus 9 meter per second. So answer is option D. Hey, is this clear, guys? Tell me in the chats, everyone. This is a trick how to solve the questions. This is a trick. Use your brain. The more you solve the questions over here, the more you are able to move forward, the more you score in the NEET. Tell me, is this crystalline clear? Is this crystalline clear, friends? And I want you guys to like this particular session as soon as possible, okay? Make the like count 500. Make the like count 500. Everybody out there. Now see. Equations of motion. Let's discuss the equations of motion. And these are the equations of motion. We say when acceleration is constant. These are the equations of motion when acceleration is constant. Guys, sir, when acceleration is not constant, what is the equation of motion? I will show you. These are the equations of motion. If acceleration is constant, if acceleration is not constant, these can be used anytime. That is, v is equal to ds by dt, s is equal to integration of v dt, a is equal to dv by dt, delta v is equal to integration of a dt. These are also the equations of motion. These also help us to find the velocity, displacement, acceleration, change in velocity. Okay. So we say, but these are used when velocity, when acceleration is not, if it is constant, we can use. If it is not constant, we can use. Now see, listen to me very carefully. See, I'm saying that when acceleration is constant, listen to me very carefully, I'll give you the feel. Let's suppose we have got a car over here, okay? You are a doctor, you brought the car, okay? And you have this car. Let's suppose initially at time t is equal to 0, it is moving with initial velocity u. It has some initial velocity u, okay? And in this case, acceleration is constant. Constant means 10, 15, 20. It is not changing. It is 10 only. It is 15 only, okay? Let's suppose it is moving and it reached exactly over here, okay? After time t, it has got the velocity. And I am asking you, how much is the value of this velocity after time t? How much is the value of this velocity after time t? We say after time t, how much is the velocity of the car? After time t, how much is the velocity of the car? You say, sir, directly. If acceleration is constant in this case, initial velocity is given. You say directly v is equal to u plus a into t. V is equal to u plus a into t. Where u is the initial velocity, a is the acceleration, and t is the time. As simple as that. As simple as that. Now, if I say, sir, if the same car has moved, we say, sir, some distance s. How much is this displacement after time t? How much is the displacement after we say, sir, time t? We have to now find the value of this displacement after time t. So we say simply, sir, the displacement in this case will be S is equal to ut plus 1 by 2 at square. Directly you will use this equation. Sir, can I use this equation when acceleration is not constant? We say no. This equation can be used only and only when acceleration is constant. This equation can be used only to find the velocity when acceleration is. And let's suppose I ask you the question, how much is the velocity of the car after traveling displacement x? This is what? This is the velocity of the car after time t. But over here I'm asking you, if it travels the displacement x, how much will be its velocity? No time is involved. We say in this case, v square minus u square is equal to 2a. This will be the final velocity in this case. So this will be the velocity v. Velocity v. U is the initial velocity, 2 acceleration and displacement x. Either you say s or you say x. Let's write s. S. Guys, is this clear? Is this clear to each and everyone? Everyone means everyone. Everyone means everyone. Okay. And one more equation is, that is displacement is nth second. What is that? Let me make you understand. Let's suppose you are starting from this point and you reach this point over here. Listen to me very carefully. Let's suppose at t is equal to 0, you are here. T is equal to 1, you are here. T is equal to 2, you are here. T is equal to 3, you are here. Now, can I say this is the displacement covered in the first second? Yes. This is the displacement covered in the second. We say yes. And we say this is the displacement covered in the third, fourth, fifth. Similarly, we say this is the displacement covered in, let's suppose if this is nth second, this is the displacement covered in nth second. How much is the displacement covered in? We say fourth second. That will be this one. How much is the displacement covered in nth second? That is this one. Okay. So this displacement in nth second will be given by u. U is the initial velocity of the car plus a divided by 2. A is the acceleration of the car. That is constant. Then we say 2n minus 1. N can be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that clear, guys? I hope this is clear. So we can write, sir, equations of motion is v is equal to u plus at. This helps us to find the velocity after time t. V square minus u square is equal to as. This helps us to find the velocity after displacement s. S is equal to ut plus half of at square. S nth is equal to u plus a by 2 2n minus 1. And all of these equations can be used. We say, sir, use only when acceleration is constant. If acceleration is not constant, they are useless. Is that clear, guys? Is that clear? Is this clear? Tell me in the chats, everyone means everyone. Boys and girls. Now, let's move on to this particular concept over. Listen to me very carefully. Listen to me very. See, let's suppose we have got a car over here and this car starts from rest. Okay. And acceleration of the car is constant. It starts from rest means initial velocity in this case is 0. Acceleration of the car is constant. Now listen to me very carefully. This is an important question. This will help us to solve bigger, heavy problems in just seconds, in a fraction of seconds. Okay. See. If I say, just a second. See, if I say in this particular case, sir, This car, let's suppose, started from this journey, from this particular point. Initial velocity of the car is 0 and acceleration is constant. This is the condition. Let's suppose at t is equal to 0, the car is over here. The car is over here. And at t is equal to 1 seconds, the car reached this point. At t is equal to 2 seconds, the car reached this point. At t is equal to 3 seconds, the car reached this point. Okay, okay. So I say I'll make the car over here. I'll make the car over here. Car has reached this point, and car has reached this point, and car has reached this point. Okay, at t is equal to. Now, my dear friends, can I say this is the displacement traveled by the car in 1 second? Yes, sir. Can I say this is the displacement traveled by the car in 2 seconds? Yes, sir. Okay. So can I say this is the displacement traveled by the car in 3 seconds? Yes, sir. And can I say this much is the displacement traveled by the car in, we say, sir, 4 seconds? Now, if I ask you, how much are these displacements? We say, sir, displacement. Directly you have to remember this. I'll not derive it. I'll not derive it. We say, sir, displacement of the car in 1 second is x. Displacement of the car in 2 seconds is 4x. 2 seconds is 4x. Displacement of the car in 3 seconds is 9x. Displacement of the car in 4 seconds is, we say, sir, 16x, is 16x. So I can also write it something like this. Listen to me very carefully. That is, displacement of the car in 1 second is 2. Displacement of the car in 2 seconds is 2. Displacements of the car in, we say, sir, 3 seconds is 2. Displacements of the car in 4 seconds is 2. It will be simply x. This is the displacement in 1 second is x. Is to, we say, sir, 4x. Is to, we say, sir, 9x. Is to, we say, sir, 16x, and so on. So you can also write it something like this. This is 1 is to 4 is to 9 is to, we say, sir, 16, and so. This is the ratio. This is the ratio. Ratio of total displacements in 1 second, 2 seconds, 3 seconds, and so on. Okay. Now. One more important point. Let's suppose we have got the same car. Initial velocity is 0, acceleration is constant. Listen to me very carefully. If I say the car started from this point and at t is equal to 1 second, it reached over here. At t is equal to 2 seconds, it reached over here. At t is equal to 3 seconds, it reached over here. T is equal to 4 seconds, it reached over here. Now, guys, can I say this is the displacement covered in 1 second, in first second, and this is the displacement covered in second second. This much is the displacement covered in third second. Guys, there is a difference. Don't confuse yourself. This is the displacement covered in 1 second. This is the displacement covered in 2 seconds. 2 seconds. Total displacement. Total. This is the total displacement covered in 3 seconds. This is the total displacement covered in 4. And there is one more thing. This is the displacement in first second. This is the displacement covered in second second. This is the displacement covered in third second. This is the displacement covered in fourth second. And the ratio of this is, guys, listen to me. This is x is to, we say, sir, 3x. And then we say is to 5x is to, we say, sir, 7x. I'll write this over here. If I have to write displacement in first second, in 1 second and first second, there is a difference. Then we say is to displacement in second is to, we say, displacement in third second is to, displacement in fourth second will be equal. We say, sir, it will be simply x is to, we say, sir, 4x is to, we say, sir, 9x is to, we say, sir, 16x, and so. Sorry, I made a mistake. This is the displacement in 1 second, and this will be simply, sir, x, and then we say is to x is to, we say, sir, 3x is to, we say, 5x is to, we say, 7x, 9x, and so. This is the ratio of displacement in first, second, third, fourth, fifth, sixth. And this one is the ratio of displacement in 1 second, 2 seconds, 3 seconds, 4 seconds. Guys, tell me in the chats if this is clear. All the people out there, please. Tell me in the chats if this is clear. Tell me in the chats if this is crystalline clear to each and every. I want to know from every single student over here if this is crystal and clear. If this is crystalline clear to each and all the people, guys, all the people, guys, everybody in the chats, everybody in the chats, guys. I need to know from everyone, is this crystalline clear? Great, great. Okay. Let's move on. Let's move. Now see. See, over here, guys, if let's suppose you're dropping a stone over here. Let's suppose you drop this particular stone. In this case also, we say initial velocity is 0 because you're dropping this from rest. Initial velocity is, and acceleration in this case is also constant, that is acceleration. Now, if I say, how much is the displacement traveled in? We say, sir, 1 second. So we say displacement traveled in or height covered in 1 second. This will be the height covered in, we say, sir, 2 seconds. This is the height covered in 3 seconds. Okay. So this, if this is h, this will be 4h and this will be 9h. This is exactly, if you compare these two, if you compare this free fall with this case, it is exactly similar. It is 110% similar. Okay. So this is the ratio of displacement traveled in 1 seconds. This is the ratio of height covered in 1 seconds, in 2 seconds, in 3 seconds, and so on. This is the ratio of displacement covered in 1 seconds, 4x and 9x we say, and so on. Okay. X, 4x, 9x, 16x, and so on. Similarly, if we say, sir, ratio of displacement covered in first second, second, third, fourth, that will be how much? That will be how much? H is to 3h is to 5h is to 7h. Like over here, x is to 3x is to 5x is to 9x. You can compare the two. You can compare the two. It's one and the same thing. On the questions, let's suppose we have got a question number 1 over here on the screen. A particle starts its motion. A particle starts its motion from rest under the action of a constant force. Under the action of a constant force. If the distance covered in first 10 seconds is s1, that and distance covered in the first 20 seconds is, we say, sir, s2. Listen to me very carefully. I'll make you understand this particular question. Let's suppose a particle starts from this point and it finally reached this point. Okay. It says that, let's suppose at t is equal to 0, the particle is over here. At t is equal to 10 seconds, the particle is here. At t is equal to 20 seconds, the particle is exactly over here. It says that this distance covered in first 10 seconds is s1. And distance, this is the distance s1. This is the distance, we say, sir, s1. And the distance covered in 20 seconds, first 20 seconds, that is, we say, sir, s2. Okay. And could you please tell me in this particular case, my dear friends, could you please tell me, sir, it is like displacement covered in 1 seconds is to displacement covered in 2 seconds. Okay. Let's suppose over here it is not given as 1 second, it is given 10. Instead of 1, it is given 10. Instead of 2, it is given 20. So this is the displacement covered in 1 second. This is the displacement covered in 2 seconds. So instead of 1 second and 2 seconds, I'll say, sir, 10 seconds, and we say, sir, 20 seconds will be equal. Instead of 1 second and 2 seconds, I'll say 10 seconds and 20 seconds. Displacement covered in 10 seconds is S1. Displacement covered in 20 seconds is, we say, sir, S2. Listen to me very carefully. Let's come over here. Let's come over here. Sir, ratio of displacement covered in 1 seconds, 2 seconds, 3 seconds is x is to 4x. So I can simply say, sir, this ratio in this case, we can say, sir, this will be x is to. Could you please tell me, this will be simply over here, that is 4x, okay? Ratio of displacement covered in S1 is to S2 is to x is to 4x is to, we say, sir, 9x and so on. Is it clear? Tell me in the chats. Is it clear? Tell me in the chats, guys. Okay. Now, so we say, sir, this is S1 is to, we say, sir, S2. It will be simply, sir, this will be x is to, we say, sir, 4x. X is to, we say, sir, 4x. X is to, we say, sir, 4. So can I say, sir, S1 divided by S2 will be simply, sir, it will be x divided by 4x. X and x will cancel. So S2 in this case will come out to be 4 times of S1. Option D is the correct option. Is it clear? Is it clear? Tell me in the chats, guys, is it clear? Everyone means everyone. All the people out there. Option D. Option D. S2 is equal to 4 times of S1. Is it perfecto? Yes. Let's move on to the next question. Let's move on to the next question. This I'll give you as homework, okay? See the question once. This is bit lengthy. That's the reason I'm giving you this as homework, because it will not waste our time over here. It will take a bit more time. Okay. Same logic you have to apply over here also. Same logic. Okay. I want you guys to give it a try afterwards. Okay. I will be showing you more questions, but give it a try afterwards. Okay. Same logic you have to apply over here. Same logic. Now, one more question. Question says that, what is the ratio of the distance moved by a freely falling body in 4th and 5th second? In 4th and 5th second. If we are releasing a body, freely falling body, how much is the distance covered in 1st second, 2nd, 3rd, 4th? Listen to me very carefully. Guys, we know the ratio, sir. Displacement covered in 1st second is to displacement covered in 2nd second is to displacement covered in 3rd is to displacement covered in 4th is to displacement covered in 5th. Okay, something like this. We know this ratio. So this will be simply, sir, this ratio is, we say, sir, it is x is to 3x is to, we say 5x is to 7x is to 9x and so on. This is the ratio of displacement covered in 1st second, 2nd second, 3rd second, 4th second and so on. Even if you release a ball, we say in that case displacement height covered in 1st second, 2nd second, 3rd second, 4th second and so on. Now it says that, take a look over here. Displacement covered in 4th second and 5th second. See. How much is the displacement covered in 4th second? That is 7x. How much is the displacement covered in 5th second? That is 9x. So can I write over here, sir, S4 divided by S5 is equal to 7 divided by 9. So 7 is to 9 is the correct answer in this. 7 is to 9 is the correct answer in. Okay. Now, one more question on this one. A body starts from rest. What is the ratio of the distance traveled by the body during 4th and 3rd second? During 4th and 3rd second. Sir, this is the distance traveled in 4th second and this is the distance traveled in 3rd second. So 7x by 5x. So we say in this case S4 divided by S3 is equal to 7 divided. Guys, if you use the equations of motion in these questions, it will take you more than 2 pages to solve. That's the reason I told you directly over here you have to remember this law. Is this clear? S4 by S3 is 7 by 5. Is this clear, guys? Tell me in the chats, everybody. Everyone means everyone. Now let's come on to the stopping distance. Let's come on to the stopping distance. Sir, what does stopping distance mean? Great, 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 great. Now, what does stopping distance mean? Let's suppose we have got a car over here. And this car is moving, let's suppose, with a speed, initial velocity u. And we say after some displacement, it is moving with some speed, okay? It applied the brakes. Once you apply the brakes, we know that it will stop after some distance. It will not stop immediately, but it will stop after some distance. And that distance is, let's suppose, given as s over here. That distance is given as s over here. So means we say, sir, initial velocity is u. Displacement is s after which it is stopping. And we know obviously final velocity has to be 0. Why, sir? Because finally it is stopping. That's why final velocity is. And guys, stopping distance means if you apply the brakes after which you stop, that distance covered is what we call the stopping distance. Okay, the object is moving with u velocity and stops after applying the brakes. So the distance covered after applying the brakes is what we call the stopping distance. Now we have to find the value of the stopping distance. So we have to find the stopping distance. I'll write over here. To find stopping distance. So we have to find the value of the stopping distance. Listen to me, how do we find? See. We say, sir, b square minus u square is equal to as. B square minus u square is equal to as. And this is the formula that we use when the acceleration is constant. Okay. Sir, in this case, body is stopping, so final velocity is 0 minus. Initial velocity is in this case u square. And we say a, and we say, sir, 2 into. Acceleration in this case is, we say, sir, we take negative over here. Okay. Why? Because in this case, final velocity is less. So if you find acceleration will come out to be negative over here. And then we say, sir, multiplied by s. Multiplied by s. Sir, how much time will you take more? It will take us more 30 to 35 minutes. Now see. So we say, sir, this is minus u square. This minus and minus will cancel. So I can say, sir, s is equal to u square divided by 2a. This is what we call the stopping distance. This is what we call the stopping distance. So stopping distance depends upon initial velocity and we say, sir, acceleration over here. Okay. Now, my dear friends, in this particular case, so after what distance the car will stop? U square divided by 2a. U square divided by 2a. And clearly we can say s is proportional to u square in this. S is proportional to u square in this. Now, let's suppose we have got a question on this one. What is the question? A car is moving with a speed of 50 meters per second. This car is moving with a speed of 50 meters. Applies brakes and stops after 40 meters. It says that this car is moving with a speed of 50 meters per second. Applies brakes and it stops after how much distance? It says it stops after 40 meters. Okay, it will stop after 40 meters. So in this case, stopping distance is how much given? That is 40 meters. 40 meters is the stopping distance. Now, my dear friends, we have the same car. Let's suppose it is moving with now 100 meters per second. You have to tell me in this case, if it applied brakes, after what distance it will stop. Let me show you how do we exactly solve this question. See. I'll make you understand. Sir, over here, I say as stopping distance is proportional to u square. S is proportional to u square. In the first case, stopping distance is 40, initial velocity is 50. And in the second case, stopping distance we have to find and initial velocity is 100. So we say, sir, over here, I can say S1 divided by S2. It will be equal to U1 square divided by U2. Directly I can write because S is proportional to U square. So can I further write it something like this? Instead of S1, that is stopping distance in this case, that is given as how much? That is 40. That is given as 40. That is given as divided by stopping distance S2. That is what we have to calculate is equal to initial velocity in first case. that is given as 50. So it is 50 square divided by. Initial velocity in second case is given as 100 square. Okay. Now, if you solve this 50 square divided by 100 square, it will be 1 by 4. And we say over here S2 will come out to be 160. Hey guys, is it clear? Hey, is it clear, guys? Tell me in the chats if this is clear. Now comes basically the next topic, that is motion under gravity. Now comes basically the motion under gravity. What does motion under gravity exactly mean? Now we don't have much left. It'll take us 30 more minutes, bro. Don't keep on irritating me, sir, when it will end. I'll stop the stream right now, and next session I won't be putting on the YouTube. Is it clear? Make sure you like this particular session, guys. And I want you guys to, when I end the live stream, afterwards at the end, you have to write the comment. How was the session and all? How was the session? And now see, motion under gravity. What does motion under gravity mean? Let's suppose I have got this key over here. I am saying that if I release it, what is the force which is acting on this body in the downward direction? That is gravity. So because of the gravity, it falls. This is what we call the motion under gravity. Okay. This is what we call the motion under gravity. Now listen to me very carefully. Listen to me very carefully. Let's suppose, my dear people, we have got a mass exactly over here. Okay. We have got a mass. And let's suppose this mass is exactly M. This mass is M. Now, I'll share the PDF in the Unacademy NEET English Telegram channel. Let's suppose we have this mass M. And we say on this mass, the force is acting in the downward direction. Okay. And this force will be what? That is gravity, which is equal to mg. We know, sir, mg is the force which acts on it in the downward direction. Now you tell me one thing. If there is a force on a body, we say, sir, if we have got a mass over here, we say force is acting on it, we say acceleration will come. Same is the case over here. If we have got a mass over here, force acts on this mass, and we have to find the acceleration. Can we say, sir, acceleration will be force upon mass? And in this case, force is how much? We say, sir, mg. We say, sir, this will be mg divided by, we say, m. M and m will cancel. So acceleration will come out to be. So my dear friends, in this case, what is this g? We say, sir, this is what we call the acceleration due to gravity. Sir, what does that mean? That means that acceleration, which is because of the gravitational force, which is because of the gravity. Because, sir, because of this force only acceleration comes, that is g. And we take the value of g as 9.8 meter per second square, or sometimes we take it 10 meter per second square also. Okay. So this is what we call the acceleration due to gravity. And if something falls under gravity, that's what we call motion under gravity. Let's suppose if I say, my dear friends, I have got this mass exactly over here, and this mass falls under the gravity. Can I say this is motion under the gravity? Yes. And in this case, how much will be the acceleration? Sir, acceleration will be g, and this g will be, sir, constant. This g will be, sir, constant. This mass falls under the acceleration due to gravity, and this gravity will be constant in this particular case. Okay? Yes, sir. Yes, sir. Now, what are the things that we need to learn in this one? Listen to me very carefully. Let's suppose, my dear friends, this is a surface of Earth. This is a surface of Earth. And at height h, we say we have got an object which we are releasing. We have got an object h. We have got an object which we are releasing. We say, sir, if we release it, initial velocity in this case is 0. Because you are releasing. You are not giving some velocity. Acceleration is g. And my dear friends, I am asking you the simple question. How much time it will take from this point till the surface of the earth, till it falls? How much time it will take in falling That's what we call the time of flight. Time of flight means how much time an object takes in falling on the surface of Earth. So if somebody asks you, what is the time of flight in this case? You say, sir, that will be simply under root of 2h divided by g. This will be the time of flight in this case. How much time an object takes in falling on the surface of Earth. So 2h by g. Sir, what is this h? H is the height at which you are releasing it. G is the acceleration due to gravity. Okay. Let's move on to this one. Next is, we say, sir, velocity of hit. Let's suppose you have released this object from this certain height. It falls, and when it hits the ground, how much velocity does it have? That is what we call the velocity of hit. Okay, when it exactly hits the ground, how much velocity does it have? That is what we call the velocity of hit. And we say this velocity of hit is simply under root of 2g, where h is the height from which you are releasing it. I hope you are loving this session. I hope you are enjoying this particular session. Okay. Let's solve the water droplet problem. See, water droplet problem means water drops falling from a tap, from a tap on the floor below at regular time intervals of time. The first drop striking the floor when fifth drop begins to fall. The height at which the third drop will be from the ground will be. Okay. See, guys. See. Let's suppose we have got the tap over here. Tap means from which water is coming out. Tap means from which the water is exactly coming out. This is a tap. From this tap, water is coming out. Let's suppose this is the first droplet. This is the first droplet which falls on the surface of Earth. This one is the first droplet. This is the second droplet. This is the third, this is the fourth, and this is the fifth. So it says that in the question, when first droplet strikes the ground, fifth droplet comes out of this. When first droplet strikes the ground, fifth droplet comes out of this tap. Okay. You have to tell me at that instant, how much is the height? How much is this height at that instant? What is the height at which the third droplet will be? The third droplet at that instant will be at what height? You have to find this. You understood the problem? You understood what is the question? It says that 5 drops are coming out. When first drop hits the surface, fifth drop is coming out. At that instant, what is the height of the third droplet? At that point, we have to find the. I hope this is clear. Huh? This is getting clear to each and everyone. Okay. Now you tell me one thing, my dear friends. In this case, we say, sir, initial velocity is 0 and acceleration is constant. Don't you think we can use that case? Sir, ratio of displacement covered in first second, in second second, in third second, in fourth second. Sir, how much will be? That will be x, 3x, 5x and 7x. Ratio of displacement or the height covered in first second, second second, third second, fourth second. So my dear friends, can I say in this particular case, this will be the net height. And this net height will be how much? 7x plus 5x plus 3x plus x. Can I say in that case? Sir, if I say in this case, sir, total height, if I say total height in this case, total height. Sir, this total height will be simply, just a second. This total height will be simply, so it will be x plus 3x plus 5x plus, we say, sir, 7x. Okay. And my dear friends, I guess total height in this case is given. You see, total height in this case is given as 5 meters. So total height is, see, from the formula we got the total height, this plus this plus this plus this. and over there it is also given as 5 meters. So we can say this is 5 meters is equal to, how much is this? X plus 3x plus 5x plus 7x. This will be simply 5 meters and this will be simply over here. Finally, I can write x will be, so x in this case will be 5 divided by, we say sir, 16. Because this is 16x is equal to 5, x is equal to 5 by 16. X is equal to 5 by 16. Can I write it something like this? Because this is 5. X is equal to 5 by 16. Okay. Now, my dear friends, if x is equal to 5 by 16, could you please tell me one thing? What is that thing? See. Sir, we have to find what is the height of the third droplet. That is this one. Can I say that height will be simply in this particular case, sir, 7x plus this 5x? Sir, this 7x plus 5x will be the height of the third droplet. Yeah, are you getting me, bro? So we say, sir, height of third droplet simply in this case will be height of third droplet is, we say, sir, 7x plus 5x, that is, we say, sir, 12x. Okay. Now, in this case, it will be 12 into x is 5 by, we say, sir, 16. Okay, that will be 15 divided by 4 and that is 3.75. Is that clear? Is that clear? Is that clear? Tell me in the chats, bro. 3.75 meters is the option. Is this clear? Is this clear? Take a look. All the people out there, my dear friends. Tell me, guys, is this crystalline clear to each and everyone? Guys, hit the like button if you have not liked the session. Is this perfect? Simple logic I used over here. See, every droplet problem, you will be given this height from there only, that is 5 meters. And you know the ratio of the distances, these distances. You add these, make it equal to this one, then you can find the, even if I say, find the height of the second droplet, can you find that? Yes, 3x plus 5x plus 7x. Okay, done. This is the water droplet problem, which is mainly asked in the JEE, and people basically fear this particular problem. Now we have the ground to ground case. Listen to me very carefully. Then we have the ground to ground case. Ground to ground case means if you have an object, okay, if you have an object, you are throwing this object from ground, from the surface of earth, and it goes and reaches the top, and then it falls back, over here on the surface. Then it falls back on the surface. This is what we call the ground to ground case. In this case, you remember one thing. If you launch an object with some velocity, let's suppose 10 meters per second, we say when it hits, it will fall with the same speed, but direction will be opposite. Over here, direction is upward. In this case, direction will be downward. Same over here. In this case, if the particle over here is going up with 5 meters per second, while it is falling down at the same position, it is going down with a 5 meters per second, but direction will be opposite. So ground to ground case means when object is thrown from the ground and it falls back on the ground, that's what we call the ground to ground case. And we take always acceleration as g over here. Now see. In this particular case, what we are supposed to calculate? Listen to me very carefully. Let's suppose if you are launching an object with a velocity u, and it goes and reaches the top, at the top its velocity becomes 0. Keep that thing in your mind. Now if I ask you, how much is the maximum height covered by this particle? You say, sir, maximum height covered by the particle will be simply, that is u square divided by 2. U is what? U is the velocity with which you have launched it, and g is the acceleration due to gravity. I want you guys to directly remember it over here. Second is, we say time of flight. If you are throwing this object from this point, it goes at the top and then falls back. how much time it will take in this entire journey. How much time it will take in the entire journey while going up and then falling back. That's what we call the time of flight. And this time of flight will be simply, that is 2u divided by g. Okay. How much time it takes to go up and falls back. That's what we call the time of flight. Okay. Now, my dear friends, we have got a question. A boy standing at the top of a tower of 20 meters high drops a stone, assuming g. The velocity of hit is. It says that a boy is at the top of the tower. Let me make it over here. A boy is at the top of the tower. Okay. And it throws a stone from the top of the tower. Okay. Which is 20 meters high. And you have to tell me when the stone strikes the ground, how much velocity it will have, velocity of hit. And we have recently studied, sir, when it comes to the velocity of hit, that is under root of, we say, 2g and h. And we say, sir, this velocity of hit is under root of 2 is 2, g is 10, h is 20. So velocity is, we say, sir, 20 meter per second. Okay. So velocity will come out to be 20 because g is 10 meter per second square, height is 20 over here. So velocity will be 20. Now comes basically the position time graph. Now comes basically the position time graph. हाँ नमाज अभी पढ़ अभी थोड़े टाइम में हाँ आज थोड़ा टाइम लग गया. Now let's come over here. We have the Ramadan that started, guys, today. You know, in Ramadan we don't eat actually anything. Okay? Nothing for the entire day. We eat in the morning, okay, at 5 o'clock, and then we will directly eat at 6 p.m. 6 p.m. or 6:30. For the entire day, we'll have to remain empty stomach. Okay. Yeah. So from tomorrow, it is starting over here. Now see, let's talk about position time graph. Let's talk about position time graph. See, my dear friend, what does position time graph actually mean? What does position time graph actually mean? Let's suppose we have got a car over here. We have got a car over here. Okay. This car is, let's suppose moving. At time t is equal to 1, the car is at x is equal to 1 meter. At time t is equal to 2, the car is at x is equal to 2 meters. At time t is equal to 3, the car is at 3 meters. At time t is equal to 4, the car is at 4 meters. Okay. This is how the journey of the car looks like. Okay. This is the real life situation. Now, I want you guys to draw this particular situation graphically. Draw its graph. Which graph? Position time graph. You have to show me this particular situation on the graph. You have to show me this particular situation on the graph. Now see, we say, sir, the graphical situation will be something like this. It will be something like this. Listen to me very carefully. Sir, we say when time t is equal to, let's suppose, 1, we say, sir, its position will be, sir, 1. When t is equal to 2, its position will be 2. When t is equal to 3, its position will be 3. So means this will be the position time graph of this situation. That's it. Position time graph means drawing the position time graph of a particular situation. Now, let's suppose I say in this case, this is the position time graph of this situation. I want you guys to exactly think about one particular thing. Just a second. Just a second. See, let's suppose this angle over here is theta. Listen to me very carefully, my dear friends. Listen to me very carefully. See, if I say, can you tell me what is the value of slope over here? You say, sir, slope means tan of theta. You have told us slope means tan of theta. And in this particular case, listen to me very carefully. Tan theta means perpendicular by base. What is perpendicular over here? That is this x. This x is the perpendicular. What is base? Base is this t over here. My dear friends, we say, sir, this is perpendicular upon base. And perpendicular in this case is how much? We say, sir, perpendicular in this case is, we say, sir, delta x. That is delta x divided by. Sir, base in this case is how much? We say, sir, delta t. Delta t. Can you tell me what does delta x by delta t mean? Delta x by delta t means velocity. It means velocity. So can I say, sir, slope of, we say, xt graph, slope of xt graph gives us velocity. So we say slope of position time graph gives us velocity. From now onwards, if I say we have got a position time graph, we are given a position time graph, and we have to find the velocity. What will we find? We will find the slope. We will find the slope. Now tell me, in this particular case, we have a question over. This is x versus t, And over here, my dear people, tell me one thing. What is that? See, let's suppose this is the car. This is the position time graph of one car. This is car A. And this is the position time graph of car B. You have to compare the velocity of car A and car B. You have to compare the displacement of car A and car B. Which one is having more displacement? Which one is having less displacement? Which one is having more velocity? Which one is having less velocity? That's what you are supposed to tell me over here. Sir, when it comes to velocity, velocity means slope. Okay. So in this particular case, guys, this A has got more slope as compared to B, because clearly this theta 1 is greater than theta 2. So this has more slope than this one. So I can simply say over here, slope of A is greater than, we say, sir, slope of B. Slope of car A is greater than slope of B means velocity of A is greater than velocity. But when it comes to the displacement, see, final point of the car is this one. This is XF. Final point of this car B is same over here. So means final position and initial position of car A as well as car B is same. So we say displacement of A is equal to, we say, sir, displacement of B. Tell me, guys, is this clear? Displacement will be equal, but velocity will be different. Okay. Now, in this particular case, you guys are supposed to tell me the answer of this particular question. See, this is the position time graph of car A and car B. This angle is given, see, clearly I can show you over here. This angle is given as 45 degrees. This angle is given as 15 degrees and this is 15 degrees. Now, can you tell me what is the angle of this B? Can I say, sir, this angle in this case will be how much? That is 60 degrees. And this angle will be how much in this case? This angle will be how much? That is 30 degrees. Why? Guys, because this angle is 45. So 45 minus 15 will be this 30. And if this is 45 plus 15 will be 60. So this B is making 60 degrees, A is making 30 degrees. Okay. This is the benefit of this particular setup. That is what I am teaching on right now. I can zoom each and everything and you are able to see every single thing very clearly. This is not possible on the smart board. Now see, we say, sir, this is 30 and this is 60. If I say in this particular case, listen to me very carefully. If I say I have to find the velocity of A divided by, we say, velocity of B, can I say that will be the slope of A divided by slope of B? Yes. And slope of A will be, sir, simply tan of theta. So tan of, we say, sir, 60. Tan of A is 30. Tan of 30 divided by, we say, sir, tan of 60 over. Okay. And if you put the values, it will come out to be, it will be 1 by 3. Hey, is this clear, guys? Is this clear, guys? Let's move on to this question. Which of the graph represents the uniform motion? Remember, my dear people, when it comes to the uniform motion means velocity is constant. When it comes to, when it comes to uniform motion means velocity is constant. You have to tell me in which case velocity is constant over here. You are given all the four graphs. You are given all the four graphs. Tell me in which of the following cases velocity is constant. Okay. All the people over here. Guys, tell me one thing. Tell me one thing. Sir, this is a straight line. This option A is the straight line. So we say in case of straight line, sir, slope is constant. Slope is constant. Yes, sir. If slope is constant in case of a straight line, can I say, sir, slope means velocity is constant over here? Yes, sir. Because in case of position time graph, what does its slope represent? Its slope represent velocity. Come over here. Sir, in this case, we can clearly say, sir, slope is first decreasing because at the top slope becomes 0. Okay. And then slope in this case is again increasing. So we say here velocity is not constant because slope is changing. Okay. In this case also, initially we say, sir, velocity is, we say, sir, positive. And afterwards we say, sir, velocity is, we say, negative. Why? Because slope of this graph will be negative. This is a decreasing graph. If slope of this graph is negative, then we say velocity is negative. So velocity is changing its direction. So we say velocity is not constant in this case. Okay. And in this case, we say, sir, velocity is 0. Why? Why? Because it is displacement of the car is constant. It is not changing. Body is not moving. We say, sir, this is not the answer. So option A is the correct option. Option A is the correct option. Is this clear? Yes, option A is the correct option. Okay, come over here. This is the last question we have over here in this case. The position time graph of a particle is given the average speed from the particle. Okay. In this case, you have to tell me the average speed. The average speed of the particle between t is equal to 0 to t is equal to 8 seconds. Okay. You have to tell me in this particular case average speed. See. From 0 to 8 seconds, you have to tell me the average speed. Guys, I'll write over here. Average speed in this case will be 5 meter per second. And average velocity in this case will be 0 meter per second. Now, your job is to find out why average velocity is 0 and why average speed is 5 meter per second. Okay. This is your job and you guys are supposed to find out in this particular case why. Okay. Okay. This is what I'm giving you as homework. Average speed means total distance traveled. Average velocity means total displacement traveled. Answer I have written over here. Homework, this is for you, and you have to basically do it by yourself. Now, come over here. Come over here. Velocity time graph. Let's suppose we have got a car over here. Okay, this is the car. This car is having at t is equal to 0, velocity is 0. At t is equal to 1, velocity is 1. And then it's at t is equal to 2 seconds, velocity is 2. Now, this is the real life situation. The velocity of the car is changing over here. And I am asking you to plot its velocity time graph. I am asking you to plot the velocity time graph of this particular car over here. What will you say, sir? Its velocity time graph would be the straight line. Simply. Why? Because when time t is equal to 1, its velocity is 1. So at time t is equal to 1, its velocity is 1. At time t is equal to, its velocity is 2. Okay. Now, guys, this is the velocity time graph of the above situation. See. I'll make you understand certain things. What are those? See, if I say this angle over here is theta, can you tell me the value of slope in this case? We say, sir, slope means in this case that is tan of theta. Slope means tan theta. And tan theta means, sir, this perpendicular divided by base. Perpendicular in this case is, sir, delta V divided by, we say, delta T. Either you say V by T, delta V by delta T, one and the same thing. Or dV by dt, one and the same thing. And tell me, what does a delta V by delta T in this case mean? You say, sir, delta V by delta T means acceleration. So can I say, sir, slope of BT graph gives acceleration? So we say slope of velocity time graph gives us the acceleration. As simple as that. So from now onwards, if you see velocity and time graph, you'll immediately say, if I find its slope means I'm finding the acceleration. Okay. Now say, sir, we say over here, slope between the 2 points will give us the average acceleration. Now, if I say, sir, slope at a point, can I say slope at a point will be, sir, that is dv divided by dt, and that will give us instantaneous acceleration. Just remember, just for the info. Slope at a point will give us dv by dt, and that will give us the instantaneous acceleration. Now, come over here. Listen to me very carefully. I'll just mention over here. Area under velocity time graph. See, listen to me very carefully. Tell me one thing, my dear friends. Tell me one thing. Sir, we have studied V is equal to ds divided by dt. Okay? V is equal to ds by dt. Now I want you guys to take this dt over there. So it will be V dt is equal to, we say, sir, ds. I want you guys to take this dt and multiply with V. It will be ds. Now integrate this. Integration of ds will be how much? That is s is equal to integration of V dt. Already discussed. Now come over here. Let's suppose you are given a velocity time graph which is a curve, which is not a straight line. And I am asking you to find the area under this curve. This area. I am asking you to find this area under the curve, this area. You'll say, sir, it is not simply, this is not a triangle. We cannot use the triangle formula to find that area. We can not use the rectangle formula to find the area. So what we can use instead over here, we'll take a small strip, infinitely small strip. This is the infinitely small strip. Of width, how much? That is dt. And its length is how much? We say, sir, its length is, let's suppose, v. Now, this small strip over here directly behaves like a rectangle. It behaves like a rectangle. And the area of the small strip, I can write area of small strip. I can write, sir, its area is also very small, dA, and that will be equal to, sir, this is a rectangle. Area of rectangle is length into breadth. Length is, sir, v, and this will be dt. Now, if we keep on integrating it, if we have to find the total area from T1 to T2, we'll integrate it. To find the total area, what will we do? We'll integrate. Let me write over here. I'll rub this. To find total area, let's integrate. So in this case, what will we do? Sir, integration of dA is equal to integration of V dt. Let's call this as equation second, and let's call this as equation first. Tell me one thing. From equation first, integration of V dt is displacement. From equation second, integration of V dt is area. This is what we call the total area. Area is equal to integration of. So can I say, sir, from first and second, from first and second, we say, sir, area is equal to displacement. Yes, yes, yes. Area under we say VT graph, area under VT. So from now onwards, you say, sir, if velocity and time graph is given, and if I ask you to tell me how much is the displacement covered, you'll find the area under the curve that will give the displacement. Slope of velocity time graph gives us acceleration. Area under velocity time graph gives us displacement. As simple as that. Okay. Now tell me, if we have got a question something like this, okay, and you have to tell me, if this is the velocity time graph, you have to tell me displacement covered. You say, sir, displacement covered will be this area plus this area. Since this area is from the upper side, it's plus, this is minus. So displacement will be A1 minus A2. Distance covered will be, distance is positive, so A1 plus A2. Directly. Okay. Tell me in this graph, in which graph motion is uniform? A, B, C. Let's suppose this is A, this is B, and this is C. In which graph, tell me motion is uniform? In which graph, tell me motion is uniform? Motion is uniform means velocity is constant. See, guys, in this particular case, you see velocity is increasing. In this case, velocity is increasing. So this cannot be the answer. Velocity is changing. C is the option. Huh? In this case, velocity is constant because this is the velocity time graph. And in this case, velocity is changing. V is changing. So this cannot be the option. Okay. And option C is the correct option. Okay. In which graph acceleration is constant? Tell me, in which graph acceleration is constant? You have got the 4 graphs over here. You guys are supposed to tell me in which graph acceleration is constant. In which of the 4 graphs acceleration is constant? Let's suppose this is A, B, C, and D. In which of the graphs acceleration is constant? In which of the graphs acceleration is constant? Tell me. Which option? Option A. See, over here in this particular case, we say, sir, slope is changing, slope is increasing. So we say here, in this particular case, slope is changing. Okay. So acceleration is not constant because slope of velocity time graph gives acceleration. If slope of this curved graph is changing, so we say in this case, acceleration is. And in this case, velocity is constant, v is constant. Means acceleration in this case is 0. In this case also, we say, sir, slope is changing. Whenever you see a curve means slope is changing. So acceleration is not constant. In this case, we say slope is constant. We say acceleration is constant. As simple as that. Okay. Now this question over here. Tell me in this case, find the displacement covered from 0 to 2 seconds. Okay. See, you have got velocity and time graph. And in this case, you guys are supposed to tell me the velocity displacement covered from 0 to 2 seconds. Guys, if velocity time graph is given and you are supposed to find the acceleration, you are supposed to find the displacement, what will you find? You will find the area. So from 0 to 2 seconds will be this area. Can I say from 0 to 2 seconds will be this area? Okay. Now tell me how much is the area over here. So we say, sir, area from 0 to 2 seconds is, this area is simply, area is equal to 1 by 2 base into altitude. Base of this triangle is how much? That is 2. Altitude of this triangle is how much? That is 4. 2 and 2 will cancel, so it will be 4. So displacement is 4 meters. So if velocity time graph is given like this, and you have to find the displacement, you will find the area. Okay. Now come over here. Find the average acceleration from 0 to 2 seconds. So we have to find the acceleration from 0 to 2 seconds. What will you say? Sir, when it comes to the acceleration, it means slope. It means slope. So that is simply delta V divided by delta T. Okay. Now guys, what is the value of delta V? That is final velocity minus initial velocity. Final velocity at t is equal to 2 seconds. How much is the velocity? That is 4. 4 minus 0 upon 2 minus 0. That is 2 meter per second. Now we have to find the acceleration from 2 to 3 seconds. Means from 2 to 3 seconds we have to find the acceleration. Now tell me, sir, when it comes to the acceleration from 2, okay, sir, it is V final minus V initial divided by delta t. Now final velocity. Sir, at t is equal to 3 seconds, how much is the velocity? At t is equal to 2 seconds, how much is the velocity? 4. So it will be 0 minus 4 divided by time is 3 minus 2. Okay. So that will be minus 4 meter per second. Is that clear? Is that clear? Minus 4 meter per second. Acceleration of this graph is negative. Why? Because slope is negative. As simple as that. Let's come on to the acceleration. See. We'll finish this and we are good to go. It'll take us 10 more minutes and we are done. We are done. Now see. Let's suppose we have got the car exactly over here. This is the car we have over here. And this car is moving. This car is moving. And at t is equal to 0, acceleration is. At t is equal to 1 second, its acceleration is. At t is equal to 2 seconds, its acceleration is. T is equal to 3, its acceleration is. Now, if I say plot the acceleration time graph of this situation, you'll say that will be the straight line. Okay. And if you find the slope in this acceleration time graph, how will you find it? We say, sir, slope in this case will be simply, that is, we say, sir, tan of theta. We say tan of theta. And that is perpendicular divided by base. Okay. How much is okay, we don't define the slope actually over here. Slope in case of acceleration time graph is jerk. That is not in our syllabus. So forget about this one. Okay. We'll directly come on to the area under the curve. Area under the curve. Listen to me very carefully. Listen to me very. If we have the acceleration and time graph, and if we find the area under the curve, listen to me very carefully. Sir, do you think that it is possible for us to find the area of this? No. We'll take a small strip. Can I say, sir, area of small strip will be dA? And, sir, this dA will be simply length into breadth. Length is A and breadth is dt. That is A dt. Now, to find the total area, what will we do? We say, sir, integration. So we say integration of dA. Sorry. Yes, this is area. This is the area. That will be total area. It will be integration of A dt. Okay. Let's call this as equation number first. Now, my dear friends, as we know, sir, acceleration is dv divided by dt. Or directly I'll write the formula. As we know, sir, when it comes to the delta v, change in velocity, that is equal to integration of A. Change in velocity is integration of A dt. Let's call this as equation number. So total area is integration of A dt. Sir, change in velocity is integration of A dt. Can I say, sir, over here from first and second, from first and equation number second, we say, sir, area total is equal to, sir, change in velocity. Area total is equal to change in velocity. Area total is equal to change in velocity. So can I just write one statement exactly over here? Let me take these. I'll just take these over here. So I'll mention one thing. That is, listen to me very carefully. Area under acceleration time graph gives us change in velocity. Area under acceleration time graph gives us change in velocity. Okay. Area under velocity time graph gives us displacement. Okay. But area under acceleration time graph gives us change in velocity. Now we have got this question over. In which graph acceleration is constant? You have to tell me in which graph acceleration is constant. Guys, if this is a velocity time graph given over here, listen to me very carefully, please. We say, sir, this is the acceleration time graph over here. We say, sir, in this particular case, if we find the slope in this case will be constant. Sir, slope in case of velocity time graph gives us acceleration. Means in this case, acceleration is constant because this is a straight line. So here acceleration is constant. Sir, now we have got the another graph. That is position time graph. In case of the position time graph, sir, its equation is x is equal to t square. See, x is equal to t square is the equation. Now, can you find the velocity, sir? Velocity in this case is dx divided by dt. Directly, I am differentiating. Sir, we are finding the velocity from xt graph. So, this will be, sir, differentiation of t square is 2t. Now, find acceleration. That is dv divided by dt. That is 2. Guys, the equation of this curve is what? That is x is equal to t square. Equation of this curve is x is equal to t square. And if x is equal to t square, we got the velocity, that's 2t. We got the acceleration, that is 2. Don't you think, sir, this acceleration in this case is constant? 2 means constant. So means in this case, sir, acceleration is constant. But remember, if I put velocity over here and time over here, then acceleration will not remain constant. But if it is position over here and it is time over here, then we say acceleration in this case is constant. Okay, let's talk about this one. In this case, you know, sir, acceleration is constant because this is the AT graph, it's a parallel line. One more question over here on the screen. One more question over here on the screen. It is saying that if initial velocity is minus 10 meter per second, then velocity at t is equal to 4 seconds is. Acceleration time graph is given. See. In this case, if acceleration time graph is given, and you guys are supposed to tell me the velocity at t is equal to 4 seconds. Can you tell me one thing? Sir, I'll just write over here, from acceleration time graph. From acceleration time graph, listen to me very carefully. We know, sir, when it comes to the area means change in velocity. Area means change in velocity. From acceleration time graph, area means change in velocity. Can you tell me the area under this graph? Sir, area will be 1 by 2 base into altitude. That is 1 by 2. Base in this case is how much? Base in this case is 4. Altitude in this case is how much? We say, sir, height in this case is 10. That is 10. Okay. 2 ones, 2 twos. Okay. Is equal. Change in velocity, that is delta V. Change in velocity is delta. Sir, what is delta V? V final minus V initial. So 2 into 10 is, we say, sir, 20 is equal to final velocity minus initial. Guys, it is saying that if initial velocity is given as minus 10, so I'll write over here 20 is equal to V final minus of minus 10. So I'll write, sir, 20 minus into minus becomes plus. If you take it over here, it will be minus 10 once again. So V. So 20 minus 10 is 10 is equal to, we say, sir, V final. So final velocity at t is equal to 4 seconds is 10 meter per second. So answer is 10 meter. Answer in this case is 10 meter per second. I hope everything is crystal and clear, guys. Thank you so much. I have covered every single concept. Now your job is to practice more and more problems. That's from your, okay? And most importantly, guys, every single one I'm saying over here, see. If I say in this particular case, if I say, listen to me very carefully. First of all, like this session if you have not liked this session yet. Like this session if you have not liked this session. See, I'll end the live stream, and afterwards, you guys are supposed to comment down below and let me know how was the session. How was the session? Everyone, I want the comments from every single one of you in the comments down below afterwards. Okay, not in the live chat, in the comments afterwards. Okay, so thank you so much for all about this. Okay, take care and bye bye. Okay, see you guys in the next session very soon. Till then, take care and bye bye. Okay, thank you. Do comment down below later on. I'll be waiting. I see your comments. Thank you so much.